Welcome everybody to Tunes Day Night. I'm your host MC Toon, and tonight we've got a debate of sorts with Doug DeArros. Now Doug has been on before, and you may have seen him on before. So all right, give me a second here. It's been about 2 years. All right, there. Where'd you go? Doug's just sharing his screen. Now they don't see you. They're hoping to see you, but instead they see this.
Oh, sorry, technical difficulty. Should I leave the room?
All right, I'll switch it. Anyway, Doug is with us, and Doug has a friend in the chat in the Zoom meeting, but he's not. He's just he's a silent watcher, a friend of Doug's, so he'll just be following along. I don't know if we'll hear anything from him or not, but he's you may see him from time to time as scenes change. And then
support audience member.
Yes, a active supporting audience member. So for those one thing, I'm going to be testing a member super chat thing. So do not do member super chats. I think there's a problem with them. I'm going to either Craig or somebody else is going to do a single test gifting of memberships. That's what's talking, the gifting of memberships. So don't do that, please. I want to isolate it. I'm trying to isolate the variable here. That's good science. Okay. Doug, did you want that to be visible? What you're sharing, or?
Yeah, this is the book, and I'm gonna refer to it by scrolling up and down throughout the interview.
Oh, all right. So now I need to. All right, can you stop sharing it for a second?
You want me to click stop screen sharing?
Yeah. Just because I'd like to introduce you at least, and then they can. There you are. All right. So now they can see. You can wave hello.
Oh, hey guys.
Okay, so yeah, I'll set it up so that they can see the book that you're presenting, and so there you go. Oh, there it is. Industrial Nerd. Okay. I was just making sure Industrial Nerd. All right. Anyway, go, Doug. Go ahead and start talking, and I'll get it so that your presentation is visible. You can share your screen now.
Okay. Yeah. Click screen share, and then be ready to go.
There we go.
Can you guys see this little triangle of this little trio of people?
The trio of people.
Only I see that?
Yeah, I don't see. Okay. I just see your book.
I see. All right. Anyways, so yeah, this is essentially an attempt to unify everything that we observe with the spherical perspective and the people on the other side of the debate, which are right now is just flat earthers, but there's more than just two possible models. So if you have a contradiction to the current model, you don't necessarily have to be a flat earther. You can explain the reason that you see things further on the distance than you should, or mirages, or the colors of the sunset with a spherical model. But rather than the Earth being a ball in space, Earth itself is more like the container. It is a sphere, but its surface is on the inside, and all of space is within that. So last time I presented this book, I started at the beginning, and that was a mistake because it was such a fundamental approach, starting off with the main assumption about these ether, that it was kind of all over the place. So what I want to do this time is start at the back and start with the evidence, the only actual evidence that I have, because the experiments that I need to do, which I discussed with Toon earlier, was the mirage inside of a vacuum chamber. If you know how a mirage works, you know that its explanation is based off of how light moves through a gas, or moving from one density gas to another. So if you remove all the gases, the mirage should not exist. And the only thing that's left is Einstein's explanation for how light interacts with large gravitational bodies such as the Earth. If you're familiar with the term gravitational lensing, that essentially suggests that light has the ability to be slightly redirected around large objects. But what a mirage in a vacuum chamber shows is that when light is traveling in a horizontal path, it does not bend down towards the ground, as Einstein would suggest. It actually could bend up against gravity, and so that should be a contradiction to what the current model suggests. And that's a very easy to understand. Yeah, I should have been following along with the visuals, but essentially this is how the experiment would be set up, and you would put a crescent hill. One kind of rule that I've discovered is that there's always a mirage at the top of a crescent hill. So if we create a crescent hill inside this vacuum chamber, we should be able to observe this curved line. And when the light gets to our eyes, the only thing we know about it is the angle that it approached us. So when we observe it, it's going to look like it's coming out of the bottom of the hill, just like a mirage does. It kind of duplicates the image of whatever's at the top of the hill right before the horizon disappears. So what my theory is suggesting is that the mirage is not simply just little sliver of the image that you see when driving or looking down long flat distances. This entire sky is a mirage, because if I think that the Earth curves up and that's the physical actual structure that it takes, then why can't I see the other side? And it's because the curvature of light itself, the phenomena or the fundamental law that is responsible for this line, is everywhere. And it's the reason that the Earth looks like a ball in space. And it's the reason why the Earth acts flat when we try to measure the curvature and things like that. So it's there's a lot of contradicting evidence that is in need of a unifying theory, and this is my attempt to do so. And do we have any questions so far? I feel like it's a good stopping point.
So yeah, so you're saying your hypothesis is that light bends upward when you remove the effects of refraction.
Well, specifically, if you take a horizontal beam, the bottom half of it will accelerate and expand outward, away from the center.
Right.
It will
What do you
increase
mean
its radius.
Accelerate.
The other half will decelerate and retract back towards the center of the universe. So we're just looking at the outside curve, but if I zoom all the way out, which is it's actually included in the thumbnail, if you saw that, talking to the audience members, not you. I know you made the thumbnail, but essentially, this is the same curve. It's the same phenomenon. It's just on a much larger scale. So the light from the sun in this diagram goes at noon, it goes straight to the surface, but at the sunrise and sunset, it goes twice the distance in the same amount of time, which is why blue becomes red. And then it goes from being perpendicular to the surface to becoming parallel to the surface, and then it starts to retract, decelerate, and become perpendicular again by going straight towards the center. So
Okay,
when we talk about things like cosmic, go ahead.
I want to be sure I understand. You're saying that light accelerates.
I'm saying that light accelerates as you get further away from the center, and conversely, it decelerates as you get closer towards the center. The center being as you increase your radius, or as you increase your altitude from the Earth's surface, the Earth being equal distance around the edge. So I'm a concave earther. I think the universe is inside the Earth, and as you increase your altitude, you're getting closer to the center of the universe. So,
so
let me zoom out.
To be clear, it's commonly held that light does not change velocity
horizontally. But let me show you an experiment that might change your opinion. And I understand that this experiment has been used to discredit the existence of the ether. But what I did is, once I learned about it, just looked it up. But instead of it being horizontal, we looked for a vertical variation of it. So I guess I should have loaded this ahead of time. Yeah,
this
if
your
you go to that
video?
website that's in the description and you scroll down to the bottom of it, you can download this PDF of the book. And in that PDF is the link to this video. So this experiment is the interferometer. And for those that don't know, the interferometer is um, a motion detector, essentially, that uses the laws of light. It tries to detect a Doppler shift along various paths. So basically, if I could just pause this for a second and back up. Hey, what's the keyboard shortcut to switch tabs?
Command tab. Oh no, switch tabs, control tab.
Control tab. Nice. Anyways, so the interferometer, the goal of it was to take a laser beam and split it into 90 degrees, and then with mirrors bring it back together and figure out if it took either beam longer than the other to go down either path. And when they ran this in 1922, they had it perfectly horizontal on a table, and they rotated it around just like in this video. Give it a second. Let me speed this up so we get. Okay, so as you can see, there is no detectable difference in the path and the time it takes for the path for light to go down either path. So that's why these vertical green bars stay the exact same. But once you reorganize or you rearrange this experiment so that you're testing the vertical rather than the horizontal, then you start to see that there is something going on with the time it takes for light to go down either path. Now, a lot of people have said that the reason that light is taking different times to go down each path is because there is a air pressure change. So this experiment alone does not prove that what I'm saying is true, but it does beg the question that if there is something going on, the only thing we need to do is recreate this experiment in a vacuum chamber. That's why the mirage in a vacuum chamber is so significant, because when we eliminate the interference that we get from the atmosphere, from gases acting on the direction that light takes, then we start to get sorry, I lost my train of thought. Told you at the beginning of this.
While you're trying to collect it, I just want to the video we saw, it was rotating all the way around 360 degrees vertically.
Right.
Okay.
So this is a standing position looking at the wall behind it in the background, and it's going up and down rather than horizontally around the table.
Okay.
And so what it's directly suggesting to us is that it's taking light longer to go down one of the paths than the other at different altitudes. And what my theory is suggesting is taking this from kind of like putting this as a piece of evidence in the middle with a crazy assumption on the end, and the ability to maybe prove, or so the speculations on the other end are, if you increase your altitude, time slows down. Or as you increase your altitude, the speed of light slows down, and therefore time and space both become smaller ratios. So the reason I say that is because the speed of light is a product of multiplying frequency by wavelength. Frequency is the ticking of time, the rate that time ticks by, and the wavelength is the actual length of something. So if the time itself, if the speed of light itself slows down by, say, a factor of x, then both the wavelength and the frequency must reduce themselves by a square root of x.
Well, hold on. I gotta write this down.
It's in the book.
I got paper. I normally play Flurf Bingo, but it doesn't apply today. So.
Oh no.
Okay. So what's the formula? You can pull it up in the book there.
Speed
Okay.
or lambda, or not speed, c is equal to lambda times f. Frequency times wavelength. Lambda is wavelength, f is frequency, obviously.
Have you done dimensional analysis on this?
I don't know what that word means.
Dimensional analysis would be you take the units of each of these different things, just the units, and then you swap just the units in for everything in the equation, right? So I've got
Oh yeah, this is common knowledge stuff. I mean, not common knowledge, but this was taught to me in physics class at college.
So we've
This
got
isn't something I made up. Yeah, the speed of light is equal to frequency times wavelength. Because if, let's say, you know that a car is 10 feet long, and you know that bumper to bumper, 10 cars can pass you per second, then 10 times 10 is 100 feet per second. Yeah, I assure you this is proper. But anyways, there's the car analogy. So if the speed of light, here we go. If the speed of light is reduced by a half, then you can take the square root of a half and the square root of a half and apply that to each of the terms on the other side. So let's say all of a sudden the speed of light was cut down in half, you would be 70% your normal size, and time would be ticking by 70% slower. So this is kind of like a direct replacement for time dilation and length contractions.
So
I feel like I'm listening to the audience.
obviously people are confused. They're like, but light is a constant speed, and he's proposing that light is not a constant speed.
I am directly challenging the idea, the assumption that light is constant.
All right, so
I'm suggesting that as these springs of ether get closer together, the speed of light slows down. And that is so that you can't get further ahead or farther behind with regards to the direction of time. So if the time it takes for the light to go from one to the other is the same, then the closer together they get, the slower they go. If the slower the speed of light gets, the smaller you get. Then the closer you get to the center, it's the infinite distance. As you approach the center, you're approaching infinity. Because if the smaller you get, you can never get all the way there, essentially. Man, this is a kind of a word salad, but
kind of all right.
I need more of an interview rather than a presentation.
All right. Where were we?
Where are we?
So all right. So I'll summarize for you here. You started with showing the interferometer and how when it was horizontal, there was not a change in the diffraction pattern, but when it was vertical, the diffraction pattern changed.
Right. And that was supposed to beg the question of, is there something going on with the speed of light along the vertical axis? Because we all know, and I agree, that there is no change in speed of light when regards to level surfaces, if you're talking about with respect to the Earth's surface.
Yeah.
But in the current model, we disregard the Earth's surface as having any significance because it is just a ball in space. But if the Earth is the opposite, then it has an extraordinary significance as being the equal distance from the center and the only concave surface in the universe, with all the other planets and celestial bodies being balls in space, essentially. So,
and by in space, you mean somewhere inside of the basketball we live in.
Yeah, with increased altitude from Earth's surface.
All right.
Outer space is now inner space, essentially.
And yeah, and typically for people who don't know, concavers think that the Earth is a sphere. We live on the inside. The size is the same. The maps are the same.
Right. So you can
you get that.
any direction.
You get that right off the bat. Everything else, I'm trouble, but those you get.
Great. We should have started on that. Here we are, two spherical earthers. But the only difference is Okay, let me ask you a question. In my model, would our heads be closer together than our feet?
Uh, yeah, verticals will converge as you increase elevation in your model.
Right.
Yep.
However, because the fifth dimension being the speed of light is the way it is, and my best attempt to
Oh, well,
understand it
hold
and
on.
explain it.
You went a little quick there on that whole fifth dimension thing.
Oh, okay. You want me to back up?
Yeah, because all right. So typically, we've got our three dimensions, and then it is taken that the fourth dimension is time, and that's about it. So you're saying that the fifth dimension is a velocity which changes.
Yes. And it's the fifth dimension because the first four dimensions depend on it. I zoomed in and completely lost mine.
Yeah, you're all over the place.
Well, it's because the top of my screen is now covered by this Zoom toolbar, and I was not at all prepared for that. Now I don't even know how to find the PDF that I had open earlier.
Would you say you're not prepared for that?
Have I ever been prepared?
You have been prepared, but you get yourself off track.
Right. I've had a lot of sleepless time.
How many coffees have you had today?
Count is 6 since noon. All right. We have a much cleaner version now. Thank God. I didn't get Zoom installed until 47 seconds before the show started. Okay. So the dimensions. So if man, you
right.
talk for a couple seconds. I'm gonna keep looking for my spot.
Oh, you want me to talk? All right.
Just for a few seconds.
All right. Yeah. So the lambda is c over f. That I mean, you've got the wavelength here. We've got the frequency. That's
no lambda is c times f. Did I say product means multiply, right?
Yeah. Well, scroll back.
Where?
Previous page? Or,
scroll back. Where I wanted.
I don't know where it was.
It took all this time to find it.
You're jumping all over the place. All right. Did you're good to go on the fifth dimension?
Yeah, we're gonna start with one dimension.
All right. Go
one
ahead.
dimension is a number line. 2 dimensions is a plane. 3 dimensions is a plane with altitude. And time is obviously the fourth. We all agree, easy stuff. The fifth dimension causes the Earth's surface to be a plane. Essentially, it is a spherical plane. You can walk in a straight line and end up where you start in any direction. However, now this is me jumping towards the end and skipping all the details, but the vertical lines do not get closer together or further apart. They remain vertical and parallel, which is, your enemy's favorite word.
What?
It's a flat Earth property. Even though their heads get closer together, they don't actually get closer together in reality because the distance between them, even though it gets smaller, the actual dimensions of space itself get smaller by the same ratio. So the Earth acts flat.
But
light doesn't travel straight, but the Earth's surface for all experimental purposes can be treated like it's flat.
But Doug, when you actually measure, verticals diverge with increasing elevation. They don't converge, and they're not parallel.
How do we measure that?
You can with
Who has measured? Okay, I'm not going to ask for evidence, but I'm saying, what if our measurements are just based off of assumptions and the actual? So here's my example that I came up with a couple months ago, just sitting in bed one night. The Voyager appears to be slowing down, and I was thinking, how could that be? It's getting further away from its source of resistance, which would
Voyager
be gravitational force.
Voyager is slowing down.
Right, the Voyager's on a one-way trip away from Earth, right?
Well, no, they're on the way back after they got through the wormhole and they were too far away.
LOL. The Voyager has no brakes. It has no extra fuel to turn around and reaccelerate.
No, Janeway just says stop. And then they stop.
I'm sorry, I can't detect the sarcasm. So the thing about the Voyager is they sent it. It has no brakes, no resistance. Once it runs out of propulsion fuel, it's just coasting forever. And you would think that the further away it gets from the sun, the weaker the sun's gravitational pull should be. So it should just kind of find an upper limit and or a lower limit of velocity, and just kind of approach it and be there.
It just
But
keep
it's
going.
slowing down, and it's slowing down in a way as if there was brakes being applied to it gradually, stronger over time. And the only and my interpretation of that
But
is
hold
that
on. Wait,
Voyager is.
where are you getting that from?
I guess I could fact check myself if I could see the top half of my screen.
Okay. I don't know why you can't see
Everybody
the
can look
top
at
half of your
that.
screen.
Because of this Zoom interface. It's covering up all my tabs, my whole toolbar, my URL tab. You guys can see it, but I can't.
Oh, well, if you you're
Oh, I can move it.
Yeah.
Amazing. All right, great. People watching me on my broadcast just saw me have that moment.
Okay.
Alan's like, finally. Okay, so, what was I saying?
You were talking about Voyager, something about Captain Janeway.
Right. Let me check. Let me fact check myself. Voyager is slowing down.
Well, it is.
Well, I usually just trying to find somebody who agrees with me, and then fact check them.
Yeah, I'm familiar with that as a as a process that some people use.
No, quick digression. I wrote most of my papers in high school just by just guessing, and then going and finding people with credibility that agreed with my guesses.
That's the wrong order, by the way.
I know, but it worked. It gave me good grades. What do you think it trained me to do? Guess and check.
Oh my gosh.
But anyways, I'm not gonna. Why is Voyager 1 slowing down? This is the gravitational attraction of the sun. So there's information out there. You can dig deeper if you want, but I'm going to stay focused on the explanation.
Okay. All
so
right.
my explanation as to why Voyager is slowing down is it's not slowing down. It's moving into a realm of space where the speed of light is slower. So what we see is the Voyager moving in slow motion. If there was a passenger on the Voyager and was watching Earth from a live feed, it would actually be watching Earth in fast forward. So in my model, I want to skip all the way back to the beginning now. The atom is inside out. The electrons are in the middle, and all of the mass in the universe is centrifuged around that. So the electrons are the stars. They're very small, they're very fast, but they're so close to the center where the speed of light is slow, is nearly zero, that they're almost frozen in time. They look really big and really far away, but they are inside the Earth, just very, very close to the center, where we could never get realistically. If electrons have a hard time getting to it, anything made out of protons just physically could never get there. Anyways, that sounds like a stopping point.
Okay.
But I guess I could keep going. I think the Earth is inside out because it is, the atom is inside out. Oh yeah, that's where I was going with it. Let me scroll up to the top. And the atom is inside out because of the existence of the springs of ether. The springs act like essentially a separator. Here. This diagram is essentially the whole theory in a nutshell. From nothing, you can get two exact opposite entities, which is matter and antimatter. Or you can consider matter to be the exact same thing as a neutron. But with these springs, this is essentially the only thing that I'm actually suggesting.
Why is matter the same as a neutron?
It's just a synonym.
But why do you have electron and proton underneath antimatter? Because electrons and protons are matter.
This is a diagram that shows the derivatives of nothing being two opposite entities in the same place. If you have matter, for argument's sake, we can assume that antimatter is defined as the opposite of matter.
Yeah.
Pretty simple stuff.
Yeah.
But if we change the antimatter into something else with this magical spring, then we can no longer lose the matter. So if we're calling the two different parts that we derive from the antimatter an electron and a proton, then naturally we're going to call the matter neutrons. So this is essentially
to draw this out, to clarify, in the traditional standard model of physics, antimatter would be positron, not electron, because electrons under
Right.
matter, and then the
I don't
antimatter
have a clue
proton would
about the
be an
physics of it.
antiproton.
So this theory is not compatible with the current model of physics. The current model of physics has a lot of digressions that go into very fine details, explaining things that were very hard to explain on the grand scheme of things. Like if Einstein was throwing a one-page essay at us, he wouldn't be talking about neutrinos and all those little thingies. He would be talking about how light functions when traveling at really high speeds.
Okay. All
This
right.
concept
All
this
right.
concept reintroduces the fundamental building blocks of matter as simple
Okay.
particles,
So
essentially.
then I want to just explore this a little bit. So then to form, say, a helium atom in this model here, helium then has two neutrons and there you have it. Yeah, two neutrons and two electrons in the center, and then it has the
Well,
protons in shells around the outside, right?
well, the difference is the electrons are nowhere close to the protons in this model. This is essentially going all the way back to
But
Bohr's model, where
but
it's
yeah,
just the
yeah,
neutron.
but the charges are flipped, so you have to have the electron in the nucleus and the proton in shells around the outside, right? Because
Okay, so
the
rather than there
charges got
being
mixed up.
individual atoms, think about replacing the definition of atom with universe. There is one atom in one universe. So in this model, we start off with a universe that only contains 4 particles right here. So the electrons are in the middle, the massive particles are centrifuged, and the pages before this explain the Newtonian physics that go into why that is, in considering the existence of these springs. Also the Coulomb physics. Then we consider a universe with more particles. The electrons stay in the middle. There are basically these leashes that prevent the protons from getting too far away, and the neutrons, for some reason, are stuck to the protons. Maybe they're just like kind of
Oh, that
mashed in there.
yeah, that's got a name.
It does, and I'm not interested in it
It's
because I have a
the
different
strong
explanation.
nuclear force.
Right. And the
Yeah.
reason I say I'm not interested in it is because I don't know it enough to explain it, and I replaced it with something that's a lot simpler, and it's simply the entanglement of the springs.
Yeah.
Yeah,
All
I
right.
know, right? Why not just start over
Yeah.
science from scratch
Yep. Why not?
and figure it out like a child? But that's what makes sense to me. If the springs exist, if I can prove they exist, then perhaps they have the ability to become entangled. And perhaps that entanglement is what keeps atoms together. And perhaps it is the proton to proton repulsion forces that that fight the entanglement and basically allow for radioactive decay over certain atomic numbers. But the
It's weird how close
fundamental
you are to
I
some
know
of
because
this.
I got 3 years of college. I almost got my bachelor's in physics. I'm not a dumbass. I'm just trying to explain this completely inside out theory to people who think I'm a dumbass.
Okay. All right. So all right. I want to review. So you've got around the outside, you've got two antimatter protons, which actually would have a negative charge, and
No,
two
no, 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 no.
what?
Antimatter is no more. Antimatter has changed
Oh,
into the pair. It has become a proton and an electron with a spring in the middle.
did they annihilate?
No, they used to annihilate. Back when it was just matter and antimatter in a universe with no ether, they were just constantly annihilating themselves. Nothing existed. That was the state of the universe prior to the Big Bang. But in this model, we assume that there was a godlike entity that was able to incorporate itself into the antimatter and separate it into energized anti-electron and energized matter and a proton.
Okay.
And therefore, the original particle of matter was allowed to exist as it did, as it couldn't because the antimatter, the anti-neutron essentially was existing prior to the spring incorporating itself.
Okay, but so I'm still having the trouble here because an antimatter electron has a what charge?
We're not going to call it an antimatter electron. We're just going to call it an electron.
But it's
The antimatter is where the electron. It's like the origin. It's like the parent particle.
It's the origin story.
Yes.
Okay, so this is like the origin story fan fiction of electrons and protons.
Sure.
Okay.
Yeah, we'll call it fan fiction. This is a third grader's guess at how the universe works.
Okay.
And so far, a third grader has grown up to be 32, and he has not yet been able to prove it wrong. And he has spent a lot of time and money trying to prove it wrong, and it just won't happen. I'm coming up with experiments. They keep working, and I need people to stop laughing at me and maybe start helping. Because if the whole world's scientific revolution depends on me getting my shit together, it's not going to happen. I'm going to keep throwing this out there. Until somebody picks
I agree.
So let's get back to where we were, going chronologically through the book.
Okay.
Now, if we increase the considered number of particles in this hypothetical universe, we can start to see that the outside shell, where essentially the heaviest elements will go to, imagine instead of like a core from the old Earth made out of iron and molten radioactive metal, you have a shell of radioactive iron, molten, etc.
Okay, so but these are helium nuclei,
right?
That are,
so let's say that all
that are bound together with some modified version of the strong nuclear force.
Right. We're just gonna imagine they're like slinkies. Imagine bowling balls on slinkies, and the bowling balls just get tangled up.
But they're industrial slinkies.
Yeah, super like titanium slinkies.
All right.
So the bowling balls get tangled, and they create these 2 red, 2 blues. Call them helium. And on the other end of the slinky is a ping pong ball that has the exact opposite charge, just as much power, but 0 weight. Now, all the ping pong balls want to be in the center because Coulomb told us that the average location of all the point charges is, you can treat that as if it was the only charge. So if you got 3 charges, you can find the average location on the plane that they create. That is where the opposite charge, like say the 3 protons, that's where the electron's going to want to go. So that is why fundamentally the electrons reside in the center of the universe, and all of the protons plus the neutrons, they have mass. And since the universe is spinning, all the mass is centrifuged, and we get this sphere. And the sphere can't, well, the neutrons can be flung off, but there's the springs act like a leash, and they prevent the protons from being flung out into the distance. But once we get to a critical point, there's the magnetic attraction from the inside protons can pull out. Go ahead.
Okay, hold on. So there's the middle thing there. That's all the electrons. Go right. Up to.
That's the same thing as inside our atom. It's just more particles now.
Okay, but so this is the moon. It looks like that.
Correct. This is slowly becoming the Earth. This thing on the outside is slowly becoming the Earth, while everything on the inside is space.
Okay.
So I'm suggesting that the sun is made out of the same stuff that the stars are made out of, but I'm also suggesting that the stars are not made out of the same stuff that hydrogen and helium is made out of. The stars may appear to be hydrogen and helium on a spectrograph, but we have to relearn what the nature of light is, and then reanalyze what a spectrograph is actually detecting. And from my speculation, the spectrograph is telling you how many electrons are involved in whatever you're looking at. And if you're looking directly at an electron, it's going to look like hydrogen, because 1 electron, 1 hydrogen, or 1 proton is 1 hydrogen. So
did you misspeak because you said electron and then switched to proton? You meant proton the whole time?
In the current model, we look at stars on a spectrograph, and we see either hydrogen or helium or a mixture of the two.
Or a handful of a lot of other things too.
Okay, but the point
Yeah,
is, in
the
this
spec
model, what
for
I'm
reference,
looking at,
the spectroscopy brings out a whole lot of other
yeah,
things
you
other
can
than
look at
just
planet surfaces. You can look at the surface of the moon, and you can find a large amount of information will tell you, like this right here. This information was derived from spectrography. It tells us what's on the surface of the moon, essentially, just by what light is absorbed, and then we can separate all the different fingerprints and figure out um, what is at least on the surface. But when we take spectrography and we look at an electron in the center of the universe in this inside out model, we still detect the same. What we're doing is we're detecting the interference that the electron gives us, and then we're interpreting it as matter absorbing light, when actually it could be something completely different, such as two electrons entangled together and then sending out a vibration that misses certain wavelengths and then gives us those fingerprints that we all know. So I'm trying not to get caught up on the details because I want to move through this conception. I know you only have 2 hours, but essentially, fundamentally speaking, the outside shell becomes the Earth as a container rather than a planet. And the inside matter becomes condensed into the same shape as the container. That is why the planets are all spheres, the sun is a sphere, the Earth is a sphere, but the Earth is not a solid planet. The moon is a solid body. The sun is a solid, well, it's not solid, but it is a spherical body. But the Earth is not a solid sphere. It is a hollow sphere
all
where the
right.
surface resides on the
Yeah,
inside.
stay on that one for a second though. So the why what caused a couple questions. What causes the moon to form there? What made it? Because it just came out of
Okay,
nowhere.
so
If you
if the
scroll up,
moon,
it just shows up one of these slides.
right. Actually, let me do you a favor. Now that I got my toolbar back, I have a YouTube video that might help explain this
Uh,
with some kind of slideshow level animation. Um, I'll give that a second to load. But I should have loaded this at the beginning. Damn. But essentially, the moon is repelled from the Earth because the moon and the Earth are both made out of protons. So you see how the arrows here are kind of pushing up on the moon, and the ones over here collectively are pushing against the moon. All the forces of the Earth magnetically push in on all the celestial bodies, causing them to take the shape of the Earth,
okay,
as
but
well as
all right, but the positively charged moon, which has only positive and neutral particles, and the sun, which has only negative particles, would attract each other with a pretty strong force. Why won't they just collapse into each other?
because of the springs, they do not allow, they essentially, it would probably be easier to program it than to explain it with words. But essentially, the springs prevent the electrons from getting too far away from the center. Because if let's say that the corresponding proton to an electron in this is all the way over here, and the sun is offset, then that spring is either going to be much more stretched or it's going to be a lot less stretched when the sun comes around. But the sun is limited to how close it can get to the center because of all the springs that are involved with the corresponding protons in all directions. So, I mean, there is mass in all of these solid celestial bodies, such as the moon, and that prevents, because of centrifugal forces, that prevents the moon from getting too close to the center. Kind of like when you do a loop in a roller coaster, you get that centrifugal force, it speeds you up. If the loops got smaller, you would go even faster. What was that, a diffuser?
Yep, a diffuser.
Oh, those are cool. Or what was the other word for it? A beam splitter?
I typically just call it a Rubik's cube.
Oh, is that not a clear? Hold on. Beam split. You gotta see this. I'll let that load and come back to it. Yeah, look at, so it does this thing where it's like multi directions.
No, it's just a Rubik's cube. It was like $9 or $8 on Amazon.
I know what a Rubik's
Yeah.
Cube is. I don't need that much of an explanation. You got to see these things. They are cool. They're crystal clear. They have film in them that has different wavelengths, so you can get different colors out of each side. But I'm not getting the image I want. Anyways, that's ADHD for you. Let me get back on track. Not even a clue what I was talking about.
The springs. Why does the moon, which is only positive, not just collide straight into the sun, which is only negative?
Because there is a spring that's preventing the sun from getting too far away from the center, and there is a centrifugal force that's preventing the moon from getting too close to the center. There is a balance.
Oh, okay. And
Sorry, we're
okay,
looking.
so then the next question. So the entire Earth is protons and neutrons, so it's massively positively charged.
Correct. Not, we can't say positively charged. It is the way that we observe it. I am just simply reanalyzing it from a fundamentally different approach. How can I explain all of this matter and the mystery of the electron with all of these experimental results that contradict the things that we were taught in physics? And I understand the train of thought throughout history, the people that learned it and discovered these things. But if we simply go back to the beginning and think, okay, let's go back to when we thought the Earth was the center. We had the functional diagrams and the paths that the planets took that were Earth-centered, and then just invert it, and we get something. It's still mathematically functional. It's just we have to conceptually explain things from a different point of view. And,
Yeah, the plausible mechanism is the challenge.
well, the evidence is it's not that hard to find. Like there's an abundance of flat earthers, and they're not all just there to piss everybody off. Some of them just generally saw the evidence and they were like, huh, it's hard to explain that with everything that we know. Science, it has to admit that it doesn't know everything, because like even gravity doesn't work. When we test the motion of the distant solar systems, they don't add up. It only works about 3% accurately, and then we have 97% missing, which is why we're on the search for dark matter.
That's so dramatically wrong.
Well, correct me in the comments, but we only got about 30 minutes left.
All right, review. What?
Or
No, I got time. I got more than 30 minutes. So
I spent a long time trying to understand everything that they were trying to teach me in school, and then reshape it so where it fits into this.
All right. So let me just a little bit. So the I don't know where you get the 3%, 97%, but we don't have super good views of distant solar systems. I think what you're thinking about is distant galaxies, and there's the galaxy rotational problem that it looks like galaxies rotate faster than the amount of mass that we can see in that galaxy.
Yeah, I used the wrong word. Sorry about that.
Yeah, so that's not 97% and 3%. I don't know where that came from. But you're probably adding in the that it looks like the universe is expanding, and the cause for that is not visibly clear. So there's a hypothesis that it is dark energy that is causing the universe to continue expanding, and that still isn't 97%, but it's a higher percentage. So,
well, essentially what they say is there must be another 97% to account for how fast the distant galaxies are spinning. Otherwise, they should have flung themselves apart.
No, not flung themselves apart. They would have different apparent rotational velocities with increasing distance from the center. They wouldn't have thrown themselves apart. And again, the number is not. I don't know where you're getting 97%, but I don't think that's the right number.
It's in the book somewhere. I don't think you want me to go digging for it right
No,
now,
no,
but I'm in the right chapter. But essentially, I just replaced the function of gravity as an attractive force with as a centrifugal force. Two components. One is centrifugal force. The other one is the magnetic attraction for every proton in your body to the electrons in the middle.
That's electrostatic. Or Coulomb's.
We're talking simply negatively charged ping pong balls and positively charged bowling balls.
Yeah, that's electrostatic.
Anyways,
All right.
so what'd you do today?
I was at work. I racked some servers.
Ooh, real job.
Yep.
There's a good page to leave it at.
What is this?
Oh, it's like a best attempt to scale map of where the moon and the sun, solid planets, the gas planets, the closest star, the closest galaxy, and the furthest celestial body would be. It's a logarithmic scale, so you start off 1 mile per notch, 10 miles, 100 miles, and so on.
So, but you switched from miles to light years.
It's the same. It's the same. It's the same length. I mean, length is. It's
Okay.
not. Miles are not the same as a light year, but it's length is length.
Yeah.
Obviously, at around 10, what's that, million, billion, trillion, at around 10 trillion miles, you're looking at 1.6 light years. So the next one logically would be 16 light years, 160 light years, 1600 light years.
Oh, okay.
Probably not zoomed in enough, but I don't want to risk it.
Yeah. So now, does it switch to parsecs then?
No, I don't want to confuse them too much. This is only 160 pages, and it's a very small book.
Okay.
It's written mostly in layman's terms.
All right.
The furthest distant object is about 100 billion light years away. So I just reanalyzed that data from an inverted models perspective, and saying that the object that is closest to the center is roughly 100 billion light years away in 3 dimensions.
Okay.
Assuming that the three-dimensional space is getting smaller and smaller as you get closer.
Oh, that's right. So space somehow gets smaller because of the speed of light.
Right, because you can define length in terms of the speed of light. Because if I say that
How is that done?
1 mile, I was going to say that at 1 mile, you're basically saying it's the same thing as 1/10 trillionth of a light year. So if the speed of light slows down, then the mile becomes shorter. And if you can measure yourself in basically light years, if you measure all distances in light years, then as the speed of light becomes smaller, then the length itself contracts. Einstein says light contracts for a different reason. He says it's because you approach the speed of light, and therefore the ratio of your speed versus the speed of light squared is how much you shrink. But I'm saying that instead of you having to go at a high speed, you just have to go to a high altitude. And then that's what the Voyager is experiencing, is that shrinking. And
just for reference, in reality, the speed of light is constant, but okay. And that wasn't quite the right.
Well, when you experience it, when you measure it directly, like you are living 1 year per year, 1 second per second, you experience things 1 foot per foot. If you got into a spaceship and you went really deep into space and you shrunk, you wouldn't be extra claustrophobic because you felt like everything was shrinking. Everything would remain observably the same 3-dimensional size. And that is because in this model, even though you're getting smaller, vertical lines in 3D space remain parallel. So the only detectable difference would be the discrepancies between your time and the time on Earth, or essentially the ticking of time. Whereas if you were basically listening to a live feed from Earth, you would hear it ticking faster if you were in space, and they would watch you in slow motion, which is what I was trying to say is what we experience when we look at the stars. We're watching very fast, very small objects very close to the center, and they look very large, very far away, and they essentially look like they're frozen in time, moving almost super slow motion.
So one dimension shrinks and the other does not?
No, all three spatial dimensions shrink in my model. In Einstein's model, only the direction that you're traveling shrinks. So you basically turn into a pancake when traveling at high speeds, according to Einstein. But in my model, you just get smaller the closer you get to the center, so that the Earth acts like a flat surface and there's an infinite amount of space above you. But it's not actually flat. It's definitely a sphere, and it's not actually an infinite amount of space. You just become smaller the closer you get, which causes it to appear infinite. I might lose you only because we have a lot of flickering of the lights going on right now with this storm.
Okay.
But if I do, just give it a couple minutes for the Wi-Fi to come back.
Okay. Man. Mr. E-Man says, can you please clear the checksum air that's occurring? No, I'm sorry. That's not going to happen. I don't know where to go. Okay. So this is what we're looking at, though. This is your model of the inside of the Earth. So now how did it go from the surface of the, I mean, it's a Dyson sphere that you kind of described there, being all protons and neutrons bound together with a different name for the strong nuclear force.
You're asking how did I come up with it?
No. How did it go from all of these positively charged protons to being what we have now, where we're definitely not positively charged, where the Earth is generally neutral?
This video should answer that question in about 60 seconds.
Okay.
After I get through the ad. So we covered this. That's essentially the Big Bang going into the new atomic model. This is a slightly larger new atomic model with the outside moving slower with heavier elements. This is where the moon draws the sun out from the center. This is the gaseous planet staying between the sun and the stars. This is a solid planet staying around the sun and the gaseous planet staying around the center. And this is the light moving through the ether. As the ether converges, light slows down. Interferometer detects no change in the speed of light along the horizontal axis, but it does detect a change in the speed of light along the vertical axis. We just have to refine this experiment in a vacuum chamber to confirm that it's not the atmospheric conditions that are causing that. So if everything I said is true, then as the vertical lines get closer, speed of light slows down.
Okay.
Or
So
vertical lines remain parallel.
yeah, I'm still curious. In the early diagrams, you had the Earth part of the Dyson sphere was all neutrons and protons, so dramatically positively charged. So how did it go from them being positively charged to what we see now as generally neutrally charged?
You see how these elements are all evenly spaced out? They have a repulsion force that the closer they get, the more exponentially they repel each other. So they don't want to be touching. When I touch this table, the protons in my fingers do not touch the table. They get really close together, and then they get extremely strong, stay away from me vibes. When we gradually increase the size of these hypothetical universes, the same fundamental principles apply the entire time. These particles all stay evenly spaced out, either from the center and from each other. And then we just start to gradually see changes in what happens along the inside.
Okay, but
So
I'm not asking about the inside. I'm asking about the outside. And right here in this diagram, the outside is dramatically positively charged. So how does it go? Go ahead.
when you say positively charged, you're basically saying that everything has a lack of electrons, and there are electrons in the universe that want to get at it. That's
Yeah.
what the current definition of charge means. But this has nothing to do with that definition of charge. This has to do with protons fundamentally exist out here, and they don't like touching each other. So if you try to push them together, they'll say no. But this is the force. I'm trying to use these diagrams to explain the force that causes them to be out here. And it's no more than Newton's forces, saying that centrifugal force is what causes mass to get away from the center. And then I'm adding the spring that causes, and going back to Coulomb's force, saying that the electrons want to be in the middle because that's the average location of all the positive charges. Then fundamentally, we can see that the electrons stay in the middle, the protons stay on the outside. And if we can just get through that kind of rewiring of how we view the model, then we can start to reanalyze individual cases on Earth, such as like what happens when we do, etc.
All right. That still didn't answer anything related to charge.
Well, your question is you're asking about a word that has nothing to do with this portion of the discussion. Are you essentially asking me that everything has a lack of, there's a huge amount of positive charge just all around us? That may be the case. Maybe that's what Tesla was starting to chip away at when he was finding this.
But we could measure it. It would be super obvious if there was basically no electrons in the matter that we interact with. Like we could not form chemical bonds because
the
chemical bonds rely on electrons, which are not here. They're all in the middle.
The current model, yes. But what we're doing is reimagining the fundamental principles of the current model, and then going in and re-updating each definition of things like chemical bonds, nuclear strong forces, and stuff like that.
Okay,
but when you talk about every definition in the possible scientific language, that is not the goal of this discussion. The goal of the discussion is to get fundamentally through the model itself and talk about where the protons reside, where the electrons reside, and why.
Okay. Well, I mean, yeah, why is at the end of this, but okay. Keep going.
The why is at the beginning. The why is this spring. This spring, if you could somehow program a computer simulation to just interact with these charges, with that lack of mass, with this mass, and these, and just tell them to entangle springs that get in the way of each other, then they would do what I imagine, or hopefully it would do what I imagine, which is the following. The electrons would get away from each other. The protons would also get away from each other. But because of their magnetic attractions and the spring included, they would act like this. And if it acts like this, then more particles would act like this, and even more would act like this, to where we could conceptually see where the moon and the sun come from. And then using the same concepts, see that the gaseous planets are not going to get closer to us than the sun will, because they want to stay in between the sun and the stars. And then the solid planets will go around the sun, just like in the heliocentric model, just inverted. All we now have to do is just re-understand how light works. And if you can understand that light getting to your eyes doesn't travel in a straight line, then 5-dimensional physics has a chance.
All right. I don't think anybody's going to be satisfied with that understands a little bit of electrostatics, but okay. Let's move on.
There's a book that you can read word for word rather than watching me try to present it.
Well, yeah, but this is a video. People are here for the video, for the interaction, not for the book.
Well, the book is available for free.
Yeah. And it's in the description.
It makes a lot more sense.
If you say so. All right.
What's Craig up to?
Craig is asleep.
That's right. Opposite side of the globe.
That's right. And in Minnesota, if the Earth were concave, I could just look up and see England.
If light were travel straight. that would be true. However, you can't look down a straight line of the road without seeing nothing more than the sky glitching as it goes transitioning across the horizon.
Glitching as it goes transisting. All
As
right.
it transitions from the ground to overcross the horizon into the sky. Observe the mirage, study the mirage, put it in a vacuum chamber, and see that it still functions without the interference of gases.
So yeah, yep, that's yeah, you should definitely do that. So there's one thing that's a little weird. So some flat earthers say that light bends upward because that is necessary for their explanation for things.
Right, and a mirage in a vacuum chamber would support that.
If you saw a mirage in a vacuum, or yeah, something shifted.
Correct, because Einstein said the opposite. He said light would bend down towards the massive object, or
Yeah,
space time would warp.
Not much on the Earth, but
Right.
yeah, on the limb of the sun is 1.7 arc seconds.
Right, there is fundamentally something there, and if you exaggerate that concept, you should see, for argument's sake, you should see something bend down. But if you see something bend up, that's a contradiction. Einstein's theory would predict something, and if the opposite were true, you would think maybe there's something wrong with that theory.
Yeah, but pretty good confirmation of light bending near the sun toward the mass.
Right, but we can also explain that with my model as well.
Oh,
Suggesting that light never travels straight. It's either expanding or retracting, accelerating towards the Earth, or slowing down, going away from it. Let me show this diagram. If I can find it. Okay, here we go. So when light is eclipsed by something like the moon, the light itself is always expanding, such as this beam that is isolated here. The light that goes straight maintains its short frequencies, being violet, ultraviolet, and then blue has much longer or slightly longer frequencies until red has nearly double the frequency, I'm sorry, not the frequency. I meant to say wavelength. Red has nearly double the wavelength of violet. So the reason that light has these different frequencies when just traveling through empty space is because it's going further distances at the same time. This diagram shows that the light traveling from the sun to the Earth is essentially the same whether it goes to the equator or the poles. But in the inside-out model, the path that you take from the sun to the equator is half the distance that it takes to get from the sun to the poles in this two-dimensional cutaway example. So if it's the same number of photons have to fill in that gap, then they have to stretch to double their length, which is why blue becomes red when the sun approaches the horizon. So that same concept applies to all beams of light, which is why I colored this diagram the way that I did. And then we can isolate that concept, that phenomenon, with the mirage in a vacuum chamber, showing that light accelerates downward, levels off horizontal with the Earth's surface, and then the top half will decelerate and start to retract and go back up. That's where the mirage comes from, where the bottom half will accelerate and either intersect the Earth or something else in its way. But light never travels straight, and it always accelerates and expands or decelerates and retracts depending on which way is up. I'm trying to figure out where I was going with that.
Yeah. All right. So, and to be clear, he wants to do this test in a vacuum chamber, and his hypothesis is that there will be a mirage.
Correct. I have not yet completed it. I built it and I lost it. Don't ask how. I know you know the answer, but I don't want anybody else to understand my life situation that much.
I'll just say it was not an Austin Powers incident.
You're gonna have to clarify for our
Nope.
viewers at home and me.
No clarification will be provided.
Damn it! All right, I have to look that up later. So when we're talking about solar or gravitational lensing, which is the light that barely scrapes by the edge of the sun and is therefore bent around it, it can be explained with the same phenomenon as to why is the shadow of the moon red. That's essentially because only the red light is able to get around the moon because it's always naturally expanding. So when you look at the sun, only the very smallest beam of light can get around it. And when you're looking at just the eclipse, you're essentially looking at a mirage around the edge of the sun. It's the same concept. It's just the curve. It's just a natural curving of light. However, undetectable because we only can perceive it as coming to us from a certain angle, which looks like it's straight line.
Okay, so within the atmosphere, the light bends enough to have different colors. But when it goes around the sun, which is significantly more massive, it does
Well,
not.
when you're looking at the big picture, like red sun versus blue sun, you're talking about very large distances going in all different directions, like from the sun out in every direction. But when you're talking about a very particular beam of light going just around the edge of the sun, you're basically focusing in on the left side of the beam of light versus the right side of the beam of light. You're not going to get a large amount of color distortion, although you will get a color distortion. You're not going to notice it as much as an entire red sun on the horizon versus a white sun in the during noon in the middle of the sky. That answer your question.
Nah, it's all right. Jeez.
But to segue, this should be the model that flat earthers are campaigning for because it at least attempts to explain why objects look like they're still on the horizon when geometry of spheres and straight lines tell us they should be concealed by the horizon. The Earth can be a sphere and act flat if we quit laughing at this thing and at least start trying to test it. If we could disprove it, I'd be happy to go get a normal job and go move on with my life.
Well, you wouldn't need a normal job. You'd have an expensive Swedish prize.
No, I mean if we could disprove my model.
Oh, there's
I
a
would
lot
be
of ways to
happy.
disprove it.
Well, please, look. If you could listen, if you spend the money to build the vertical
No, that's
mirage in the
not the only
box,
way to falsify it.
and it works, and it disproves my model, I will pay you for all of your time and the materials. I'll write you a big IOU. I'll start sending you a monthly check. But as for me, even just coming up with an extra $1,000 to put together is not going to happen. I
Okay.
spent 10 years trying to do it.
You 10 years trying to what?
I've been spending 10 years trying to create the experiments, paying for it out of my own pocket on this treadmill bullshit society. And it's just, I don't have the ability to fund my own research. And apparently I don't have the mental capacity to ask for a research grant either. What I do have is the unwavering ability to beg people to focus on this thing. And as long as everyone looks at it like it's a joke, I guess I'm just wasting my time. But if one person out there looks at this and says, okay, maybe this guy dedicating his whole life to this book, this theory, is onto something, I'm going to at least help him find out that he's not, or we're going to get rich finding out that he is. That's my message to all of your viewers out there.
Yeah, all right. So viewers, I'm kind of getting the idea that should you assist Doug, and if he gets that Nobel Prize, you will be on the stage with him.
The experiments are ready to go. All we need is to start measuring the altitude of a horizontal beam of light and then create a little plastic box and suck all the air out of it and just peek inside to see a little mirage on the ground. Or even take it one step further and actually create the interferometer inside a vacuum chamber. We can make it the size of a keychain with 3D printing and just get some cheap parts off of AliExpress or whatever. You can get like a bundle of 100 beam splitters for like $50.
The quality might be something you should focus on. If you're
not
getting
measuring
something from AliExpress, it's not the right place.
Yeah. Well, I mean, I spent $150 on a single 3 millimeter glass cube that had a filter in it to separate a green laser 50% in either direction. One half goes straight, the other half go right. And that set me back like 2 or 3 months worth of. But fundamentally, you're not the interferometer. This and for this purpose is not there to calibrate or calculate anything small. It's just there to show a fundamental change along the vertical axis versus the horizontal. If you could point it and move it around the room, I have a video of me making this prototype out of Legos. I know it's really shittily put together, but it works. You point it, you slide it, it doesn't move. You tilt it up, you put it back down. The green bars, they shift left and right. All we got to do is put it in a vacuum chamber. And if it still happens, I mean, I'm not sure what else to do other than go another $100,000 in debt to finish college and then go write a paper and have someone tell me I'm wrong again. But, I think streaming nonstop and getting on shows like this and just talking to people and at least arguing with flat earthers until they give up and block me, it seems to be the only path, that option I have.
Well, they're good at blocking. That's one of their skills.
I can understand why you think they're trolls, but I can see their frustration. When you think you've got something and everyone thinks you're wrong, you just want to tell them that, no, you're wrong. You've been misled. But if both people stop and try to understand why the other person thinks that way and really get an don't just point out the contradiction, but see what it is exactly that makes it so irrefutable to them. And the same goes to flat earthers. Like, you can't just tell regular people that NASA's been lying to you. I'm sure that NASA probably fudged a couple results on some things and they got caught, but it doesn't mean that they've never been to space. It doesn't mean that every single video out there is faked. It just means that there's something worth raising an eyebrow over, but it doesn't mean that everything is a lie. We have to take in our observations and try to explain them. Sorry, go ahead.
So you did say if it can be falsified, then you'd move on.
Absolutely.
All right.
That would be a dream come true.
So PhD Tony is in the chat, and he said he sent a super chat. He said, "We have abundant seismic evidence constraining the geometry and composition of Earth's interior. It's not hollow. Also, where does the magma from volcanoes come from?"
Right. I've thought about that. It's still, that isn't as fundamentally contradicting as showing me a lack of a mirage in a vacuum chamber or showing me a failed vertical interferometer inside of a vacuum chamber. Seismic interactions can travel through a ball. Like if you had a basketball and you flicked one side of it, everywhere would have a vibration, except the exact other side would have an extremely higher vibration. It's called constructive interference. It would appear as if the flick, the energy from your flick had gone directly through the ball. But in reality, it is just a wave that goes around the ball, and then once it gets to the other side, it all adds back up, and it punches whatever's on the other side of that ball. If you flicked.
That's a good point, but you do know that there are different types of compression waves.
Yeah.
Right. There's longitudinal and transverse.
I remember having this discussion with my physics professor over whether or not seismic interactions and detections and calculations, all that.
Yeah.
It doesn't fundamentally disprove it. It just shows that there's explanations that work well with the old model. It must be impossible for them to work well with your model because you have a giant hole in the middle of it. I understand that there's a giant hole in the middle of it.
What?
But it doesn't disprove it.
We don't have a giant hole in the middle of it.
It's hollow.
Oh, yours does.
Yeah.
Yeah. So what I'm saying is there are more than one types of waves that you get at a sensor. So there's an earthquake.
Right. There's like up-down wave and left-right waves, essentially, right?
Compression.
Correct. Compression is left-right.
No.
And
no. Compression is
what's the two?
Go to your slinky again. Go to your slinky. Pull it out long, right?
Right.
And then I want to. Right, you've got your long slinky.
You want to wiggle it,
and then
like a guitar string.
Wiggle one like this. Yep, that's one way. Now you can go this way. But what I'm talking about is compression. Go this way with it, and so then you've got a compression wave that goes along this way, and it goes faster than the horizontal or vertical type waves.
And what I'm saying is, in this hollow Earth model, compression waves can reappear as up and down waves due to the nature of constructive interference. And I'm not saying that this is true. I haven't done seismic interference experiments. I have only done conceptual thought experiments, and I have written them down so that they can be understood and tested, at least on the surface level, very easily.
But this is a falsification test for concave. You didn't give us an explanation. You just
I
kind
don't
of
understand where the falsification is. Is there data that uses a concave model accurately and says that, okay, this would not be able to be possible in this model, and that because it exists in the real world, this possible model cannot exist?
you can test your model using the data.
Who has tested it? Who has used a concave? Okay, I don't
You
want to
could.
go into
You
case by
could.
case experiments. I want to stay conceptual so that the audience has the best understanding of what I'm proposing. I don't want to defend it because I haven't done. I've said I haven't even been able to make 2 individual experiments completed. Of course, I haven't gone and done seismic testing or learned every
You
piece
don't
of
need.
data out there.
This is a beautiful thing. You don't need to go do it yourself. You can just go access the data. There's many sources of publicly
Okay, but it's about
available
interpreting
seismic
the data. If the people who are listening don't understand this enough to see what I see, and I don't understand a lot. I'm a very simple-minded, just essentially a guesser. But
I agree.
Yeah.
I know I'm not trying to pretend like I'm like a genius. I'm somebody who stumbled across something that many people have stumbled across, but their interpretations of it are so far-fetched that it is laughable. But my interpretations of it are not just random, like, word salads. They're actually like in my head, which is hard to get the idea out of my head through the video and into everybody else's head. But I'm doing my best to show with the help of these diagrams that it's not impossible. And what you're telling me verbally, I don't have the data in front of me. I haven't reviewed the data. I definitely don't have the time or resources to obtain it. So
It's free.
I understand it's free.
You don't need any
help me find the
resources.
time to get to it. I'll add it to the long list of things to do, but
Yeah, no.
it shouldn't bring the conversation to a pause.
No, but this is the falsification. We're like, if it could be falsified, then you would give it up. And if you were honest about that, then looking at seismic waves should maybe go to the top of your list.
Okay, but what you have failed to do is explain to me in a convincing, simple way that makes me shows me that it's impossible for your model to function with this. When I say I could clearly see how seismic waves would act totally different, and an interpretation could resolve that adjustment. So everything needs to be reinterpreted eventually.
Yeah, I mean, I'll glad to explain it to you a bit here.
Sure.
So if there's an earthquake that's a bit underneath the surface of the Earth, it takes time for the different types of waves to get to different places. So the waves that travel through the Earth get to the other sensors faster than the waves that go on the surface of the Earth.
Time doesn't even tick by at same altitude.
You gotta let me explain it. You gotta let me explain it. So the amount of time that those waves take to get from the earthquake to the sensor, when you look at the distance inside the globe and look at how fast those waves transmit, the distances make sense. Now, you don't have on concave Earth, it can't even go through the Earth. It can only be transverse across the surface, because into the concave Earth, you have basically 2 ideas. The matter just keeps going, or it's a shell of some sort. Okay, so there you go.
Time does not tick by consistently at all lengths of the Earth's or the universe's radius. So if you go into the Earth, time is moving by faster. If you go up above and you increase your altitude from Earth, time moves slower. So if you're using time as a arguing point, you have to have a functioning model that accurately incorporates time into the concave Earth to even begin that argument. I would be happy to take in the data, but I've got to have a functional model that I can at least input it into, and programming that is the next logical step. So it doesn't fundamentally simply discredit or it doesn't take away the possibility of the Earth being concave. It simply just raises a point that we need to reanalyze this data and see if it can work with that model. There is two pieces of information that would fundamentally disprove my model, and that is a lack of a mirage inside of a vacuum chamber and a totally fixed interference pattern moving in all dimensions inside of a vacuum chamber.
Well, there's other things too. There's many
But the other
things that
things
could
are
falsify your model.
arguable.
There's not
They
just
don't
two.
they falsify models that fail to incorporate the change of time over the change of altitude, and altitude includes digging downwards. So if vibrations are,
it's not that though. It's not. So the amount of time that it takes confirms the globe. Hold on. The amount of time that it takes confirms the globe. But if the Earth were concave, the waves that we measure going through the Earth, the globe Earth, the living on the outside of the globe Earth, those waves would never get to you on concave. They would not exist. You would only get the waves that go along the surface. The other waves could never get to the other point because they don't have an Earth to go through. They can only transmit away from the center of the earthquake, and you wouldn't get to 170 degrees away from the epicenter on the surface of there. They never get there. You'd only get the ones that went on the surface.
So in this concave model, as opposed to old concave models, the surface, you cannot treat it as concave. You have to assume for all experimental purposes that it acts flat. So in this model, you essentially
that doesn't help you though.
Not yet. But in this model, you have a flat surface, an earthquake underneath of it, and a most likely infinite amount of depth. So if you're talking about an earthquake traveling underneath of you, you have to include the fact that light will, and so will space and time, will vary in how it acts as it goes. And it may very well support a spherical model, because so far everything has supported a spherical model. But with enough interpretation, it can still survive the test. And I'm saying that a seismic wave data analysis does not give enough fundamental convincing evidence such that like the mirage or the interferometer would. That would be so more clear cut. And I don't know why we're getting hung up on this comment from somebody. Is it because he paid $5 to post it?
It's because he really knows his topic.
I would love for him to really know his stuff, and I would love for me to know all of it. But that is not going to happen in my lifetime. I am only going to know what I have spent a long time trying to conceptualize visually with these diagrams and these words. And I know that there are going to it's going to require more people than just me to get all the answers, but it's not dead. And a seismic vibration is not, you have to at least understand my model enough to know what you laugh every time I say the word flat, but until you understand that this is fundamentally how it works in 3D,
okay,
then we can't begin to reanalyze any experiments.
We can, because if it acts flat, that doesn't help either. And I'll read this here. He says again, Tony says, seismic wave arrival times are not linear with distance. Distant signals arrive earlier than linear extrapolation. This is inconsistent
and light
with the geometry.
Linear either.
This is inconsistent with the geometry of both flat and concave Earths.
But the geometry of the flat Earth is we've barely even started understanding how it works. We have where light doesn't.
The geometry isn't that difficult. The geometry is rather simple.
Geometry is difficult when we have a system that bends light naturally. If light doesn't travel straight, of course times are not going to be linear or curvature as you would expect.
All right, so it sounds like you have an unfalsifiable position.
No, I'm not saying it's unfalsifiable. I'm saying that one particular bit of data does not falsify it yet. It may very well do the job, but we have to at least have a valid concave model to test against, because my model could very well do the job of explaining it. We just have to get it to where it's testable. And right now it's barely explainable and it's still in the laughable stage. So until we get at least a computer program that's able to represent it, then yeah, I guess I'm just gonna have to keep doing talk shows like this.
That there are 4 or 5 concavers out there that might
Yeah, I've had a couple conversations in the Facebook groups, and they're very argumentative as well. I try to agree with them, and they still attack me.
Have you hung out with Sam Owens?
I haven't left this house in 2 months.
I don't mean in person. I mean online.
No, I don't interact with people as
Yeah.
easily as most. So
You might have a good time talking with him. To my knowledge, he's the current only concaver that thinks he's Jesus.
yeah, I've heard that. That
So
tends to happen.
yeah, so
Kind of
we're at 1 right now, which is kind of a
if
low.
Jesus had an iPhone, what would Christianity be like?
I don't know, but we do know one thing for sure: Sam's not Jesus. He's just a very naughty boy.
Yeah.
Oh my gosh! All
Theory
right.
is quite irritating.
Yeah, I think it might be. Maybe you could join forces with him. That might be fun.
I mean, if he's got a few $100s to throw at some plastic experiments, I'd
Oh
love to.
dear, no, he has nothing.
That's also a tendency amongst all the flat and concave earthers. They have nothing.
True. Yeah.
No data to back themselves up,
Where-
just a bunch of diagrams that they made up themselves.
Yeah. Where did you go to college, if you don't mind me asking?
University of North Carolina in Wilmington. Dr. Davis was my physics professor.
Okay. Do you think Dr. Davis would would back anything you say here?
He was kind of on the fence with a lot of stuff because he took information that I presented to him one at a time. So sometimes my diagrams they really hit home with him, but sometimes the more macro scale conceptual things he kind of disregarded before I was able to finish explaining them. But no, like most people, like the more they understand, the more red flags you see. And that was the only real edge that I had as a young thinker. I didn't know enough about physics to stop myself in this train of thought. So to take this all the way and create what I believe is a fully functional model, at least conceptually, it yeah, I forgot where I was going with that.
Well, a model includes causal mechanisms too. So why things happen, and so you might want to fill in on a few of the things on causal, and of course that requires
Besides the spring, what am I missing?
a few things.
For certain.
Well, I mean, yeah, you say that light bends up. I don't know. Is there a cause that you even propose?
Yes,
really?
I say that the reason light bends up is because the time it takes for light to get from one spring to another is the same no matter how far apart they are. So as they get closer together, the speed of light must inherently slow down. And that is why light curves. It's because its path, although physically is straight, there are these springs that it transmits through, and they dictate how it acts.
So, okay. It sounds a little bit analogous to Snell's law. In Snell's law, light bends towards the denser medium.
Right, that sounds more like gravity. This has nothing to do with gravity. This is moving through an
No.
entirely brand new concept.
Snell's law is not gravity. It's
Moving
about the
towards
medium.
dense. If the theory that you're referring to doesn't have the springs in this format to where they're all in the middle, they all spread out as they get closer to the edge, and they transmit light, then there's no functional reason to compare them.
They transmit light?
Of course they transmit light. They're the medium that light travels through. That was the first
The
part.
springs are the medium.
Yes, they are the ether, the luminiferous ether. So one thing that we gave up looking for in 1922 with the horizontal interferometer.
Oh, what? The springs. Oh my gosh. The springs are the luminiferous ether.
Yes.
You know they have
They're responsible.
string theory with a T.
Not string.
You could just call this spring theory and get a little like piggyback on the popularity.
Yeah, I've considered that.
There you go. Now, if
But
you
I know
could,
you got a show here in about 30 minutes. I don't want to take up too much of your time. Give you a little bit of a gap.
okay, I have enough time. The next one is at 10 Central, so I have an hour and a half almost.
Oh, okay.
Yeah,
That
I
makes
shifted
sense.
things to make sure we didn't get too pressed for time. And then actually, I was going to have Takori on, but Takori had a schedule conflict, so I have a different thing other than Takori. So,
Okay, yeah, well then let the
yeah.
show continue.
Well, we have some questions from the audience, if you don't mind. Some,
Yeah.
because
Not bad.
Icy Spin says, I'm here for the measurements of flatness or concaveness.
Well, if you try to measure it, you won't be able to measure any concavity unless you're solely measuring the path that light takes and then reanalyzing it through the lens of possible concave surface. But it will measure to be flat for all experimental purposes, is my speculation based off of everything I know.
All right, so no measurements, but you speculate things will measure flat.
Well, there's only a handful of data that I was able to use, and to create a curve in geometry, you only need 3 points. So that was enough for me. But yeah, real world data.
In two dimensions, you need
Experimental
3 points.
I was just talking about two-dimensional geometry as an
Yeah.
analogy. But if you treat the Earth's surface as flat and you treat light as not straight, then that's what is required to analyze things through the lens of this theory.
Do you think space agencies are lying, or are they fooled
No,
by the physics of light when they see a globe? Asks Mandevil.
I believe if they are aware of this theory, then they're probably also aware of how difficult it is to grasp, and they don't want to confuse people, or it's so beneficial to understand that they don't want to share it with anybody. But as for lying, I highly doubt that their job is to go out there and just launder money and under the guise of falsification of space videos. I doubt that it's their
So
main goal.
they're fooled.
They're probably not fooled. They probably understand this. And they also understand that it's not something that the public really needs to know.
So you think
It
they're
doesn't
lying?
change anything about reality. It just changes the way that we interpret data.
So you think they're lying? If they
I
know
guess
about it,
if
if they
concealing the truth is lying, then yes, they may be lying. But I don't
concealing the
think that
truth
lying
is, yeah,
about what they
that
know.
definitely falls within the definition of lying.
Okay, yeah, so we agree on that definition.
Yeah.
I don't think that they're lying about everything. I do think, and it makes really it's obvious that of course they're not telling us everything. So yeah, by definition, they must lie, because if they were honest, we would have way too much information about everything and we would go crazy. So yeah, they're hiding a lot, but they're not creating an endless amount of false data to cover up the concept of space itself.
But they would
They're
have
not
to,
like
because the ISS, there's a large amount of video from the ISS every day.
Yeah, I
So
believe the ISS is up there. I believe that the video is taken in, the light comes in from certain angles, and we interpret it under the assumption that the light is traveling straight.
how is the ISS up there, as you say?
In there, it's increased altitude
but
from
how? But how does it stay aloft?
the same concept that keeps the moon up there. It's, I guess I'll
Springs?
send you. No, it's
But isn't the moon kept up by springs?
no. The moon is kept up by Coulomb's law, overcoming the centrifugal force of a spinning universe. It's attracted to the sun. The sun is made up of negative stuff. The moon is made up of positive stuff. They're in direct attraction to each other. When you go to the moon, you're at the place that the moon wants to be. So you're attracted to the same location because you're also made up of positive
But
stuff.
why doesn't the ISS just collapse into the sun then once it gets up there?
The same reason the moon doesn't collapse into the sun and all the planets don't collapse into the sun.
Springs?
I don't have a 3D model programming that's there to show you
But
all of the physical functions of the
is it
ISS. But I'm telling you
springs?
conceptually that it's the same reason that the moon is there. When you land on the moon and you stand on the moon, the same forces are acting on you as are acting on the moon. And so if you're there and the moon's there, you're in the same spot, you're going to be on the moon. The universe is putting the moon there. It's going to put you there if you get close to it.
But I still don't know what's keeping the moon from or the ISS from collapsing into the sun. Is it springs?
It's Newton's laws and Coulomb's laws working at the same time. It's a balance. It's always been in a balance. It will continue to be in balance unless we start to put a lot of stuff on the celestial bodies, like colonizing Mars. Bad idea.
Oh, jeez. Okay. So it's not springs. It's
The matter has the ability to move through the springs. They're different. They're entities based off of different. I don't know how to define that word, but the springs fill all of space. They go from the middle to the edge and they fill all of space. One proton, one spring. There's a lot of protons out here, so there's a lot of springs going from the outside to the inside. And light vibrates by inducing either electric or magnetic waves, and they oscillate through the springs, seemingly through empty space. But we're not even considering the existence of them. So of course we don't understand them enough to test against them. What I'm trying to do is at least introduce the concept of them so that we can start to get better understandings and better experiments.
okay.
But I've got 2 experiments. They would do a great job to say, yes, let's keep going, or no, let's throw it away. And I'm reaching out for assistance.
All right. Well, if anybody's out there and there's some concavers that might watch this, then contact Doug. Do you have contact info on your website?
Oh yeah.
Right,
BibleScience.com. It's everything's there.
Yeah, and his email, his website is linked in the description. Tim Tully says that this is word salad with pseudoscience dressing.
Yep, sure is.
All right. William Foley says, dude, you almost broke Facebook with one post. Hope you had a great trip. So I flew to Phoenix this weekend. On Friday, I took a picture of myself in the airport, and I asked flat earthers to present a prediction for the dip of the horizon for flat Earth. And I included a prediction for the dip of the horizon for the globe. Last I checked, there was over 900 comments on there, probably over 1,000 now, and not a single flat earther could predict the dip for flat Earth. None of them know their model well enough and have an understanding of their model at all to do a basic test of their model. What should the dip be?
Here's the dip. Is the altitude from this red bar to this green line extending the red bar in the direction that it's currently going. So in the current model, if we just ignore the gaseous interference of light, we just assume that light travels in straight lines. This is what the line should be. And this is a conceptual view with only a couple data points of what that line will do. It will act as if it were supposed to stick to the Earth as gravity predicts, but then at some point, it will re-find a parallel path with the other line. So if there was somebody standing in between these two, he looked straight up, all 3 lines will become parallel eventually. And this line will give you an apparent dip. But like I said, for experimental purposes, we assume that there is no
But
dip,
but
but we can
why?
calculate an apparent one
What causes that?
conceptually.
What causes that
It's just
though?
a 5 dimensions. The way the speed of light acts.
Okay.
If you read the book, it'll make a lot more sense than if I just try to word
What's
salad
all
an
right?
explanation together.
Altitude equals c minus a. Is c, what's c here? Speed of light?
Oh, C is this line. I was
Oh, okay.
trying. This is just using trigonometry to take this hypotenuse and subtract the radius of the Earth to figure out the altitude of the shadow.
Okay. And then in the bottom, what's the formula? It looks like a cube formula.
No, this is no formula. This is just showing that conceptually you won't get a straight line. You'll get a line that curves down and then curves away. And so there should be no explanation in any model that explains that. The only explanation, if this is true, is that this surface is the opposite, and this line is doing something along the lines of this. So, like, for instance, the flat earther's favorite Chicago example, or Lake Michigan, seeing Chicago over 50 miles and having 70% of the building visible, where only 0% of it should be visible. That's only
But
one data point,
but
but
but that's the but that's not the prediction for the globe though.
it's the same curve. That curve, if I could get this curve
No,
accurate
I just want to
according to
point
real
out
life.
I just want to point out that that is the prediction for the globe is not that it's completely obstructed. That's not the prediction for the globe. So
If you assume that the light travels straight and you assume that the globe has a radius of 4,000 miles, then at 50 miles, there should be about 1,400 feet worth of a
yeah,
drop, according to
and
spheres and straight lines.
the other part that you've assumed is that the observer's eyeball is half submerged by the water.
Nope, 6 feet. I included that in that.
Okay.
Yeah. No, I actually used math. I just didn't include all the scratch work in the book itself. I try to keep it as conceptual and easy to understand as possible. But yeah, at 50 miles, there's a 75% discrepancy, and I'm going to use that as the apparent dip of the Earth. But this green line conceptually would show what my data would look like, and this one down here would show if the Earth were treated as a flat surface and you go 25% of the way around it in all directions. This is this is basically half the Earth. The red line is the current model's prediction. The blue line would be my prediction. So yeah, with a couple experiments and some real life data, especially out there at the salt flats, I would be happy to give you a actual curve.
But people have done the measurements at the salt flats. A friend of mine, Baron Rutledge, went to the salt flats and used theodolite to measure reciprocal
Well,
zenith
unfortunately, the
angles.
salt flats are only 12 miles to the nearest mountain.
Yeah.
Chicago across Lake Michigan gives you 50 miles. That's more than the salt flats can give you. So we've already got 75% discrepancy.
But why
at
did you
50
bring
miles.
up the salt flats?
To get closer. Yeah, you're right. Good point. I should have brought it up. It was just more like rambling.
All right. Okay, Stringer News 1. What is C in the medium of imagination?
Not sure what he means by medium of imagination.
Probably speed of light here is C is speed of light, right?
Great question. Thanks for asking it.
Okay.
What's next?
MK Ultra comes in with a little bit of a jab here. Says people in the chat are wondering when our guest will be picking up his Nobel Prize for disproving the constant speed of light.
I highly doubt I'll be getting it in my lifetime.
Now, seriously, people would be excited for somebody to disprove the constant speed of light.
I used to be so excited, man. It used to be my dream as a kid, but as I went from a kid with a dream to an adult with a dream, it started to become more like a nightmare. A Nobel Prize would make all this bullshit barely break even.
I don't actually think you put that much money into it.
Not money, but aggravation. Like if I had to sue God for a Nobel Prize right now, I would still feel like I didn't get enough out of it
Yeah, sue
if
him.
I won.
Sue him
No
for
shit.
that.
But I was saying, like,
All right. All right.
metaphorically speaking.
Industrial Nerd says, if line dancing is, well, this is you. If line dancing is one dimension, you've seen line dancing, right?
Yeah.
It's
Okay.
in a line. Square dancing is 2 dimensions.
Hmm.
Would cube dancing be 3-dimensional? And what would dancing be like in the 4th and 5th dimensions?
Well, the 5th dimension would be Dyson dancing.
How would that look?
I actually still don't know what a Dyson sphere is, but you seem to think it's a valid answer.
Your model is
Your
a
head's
Dyson sphere.
in 5th dimensional dancing, you would be standing on the inside of a sphere with your heads almost touching, but you would feel like you're standing directly apart on a flat surface.
All right.
Oh, here's a better version of that answer. Imagine you go to the amusement park and there's a gravitron and it's spinning so fast that it starts to accelerate light away from the center of it. So it starts to look flat while you're standing on the wall.
They'll stop it if you stand up on the wall. They're no fun. Todd's Tech Tales says time slows at altitude, so flying from Australia to the US means I'm younger than those I left behind. Neato.
Correct. So are astronauts by about 13 milliseconds per year at an altitude of 400 miles. So you're not getting more than a fraction of a millisecond, and you'd have to spend an entire year in an airplane.
But that's enough to bend light how much you need it to bend?
Yes. Now here's actually, this would be hard to really get into, but think of the circumference of the Earth being 25,000 miles. If gravity is 9.8 meters per second squared in the down direction, then the radius would have to be 1.1 million miles with one rotation per day in order for it to be valid in my model. So the radius is going to be one dimensionally 288 times larger than the circumference, which that's supposed to highlight the concept of a sphere acting flat. No matter if you fly around it or you walk around it or you dig a hole and you crawl around it, it's always going to be a 25,000 mile circumference, which is why I call it a flat property. So the 5th dimension basically takes a circle and makes it into a straight line that has a looping
Wow.
feature.
So I'm reading pilot Ron Wagner. Who's that?
Your guess is as good as mine. You could probably look them up and you'll find the same data that I found.
I don't know. All right. Well, somebody's wondering.
I wasn't turning this book into a teacher or anybody, so I didn't feel like following MLA citation format.
Okay. MK Ultra says, according to the dictionary, neutron is not a synonym for matter. Just saying.
It's currently not, no, but in this model, we are redefining a lot of words, which is why in my
do you
on my
have
website,
do you have a vocabulary section?
yes. If you click on argue, whoops, and you go down to the debate system, we have a list of words, a list of statements, and a list of arguments that the goal of this list is to create definitions that both flat earthers and round earthers and concave earthers can all agree on. So start with defined words. We're not going to go through all of these, but just a couple examples to get an idea. Oh, the internet. So slow. So anyways, the example for the word day, when the path to the sun is a straight line to an observer standing on Earth. Everybody, flat earthers, round earthers, they all agree with that. But if you say day is when the Earth is on a particular rotation and the sun is over there and the Earth is a ball in space, then flat earthers can't use that definition of the word. So before we get into these long-winded word salad debates, we at least need to get a list of definitions that we can all agree on and then connect them using the Boolean operators, if, then, and or, so that we can use easily defined and agreeable words to create statements that are easily polled as true or false. Then we can take all the true statements, connect them with ands and ors, or nots, and ifs and thens and senses and thus and all that. And then we can eventually get like simply yes, no arguments. But yeah, that's about as far as I want to go. This is a
Professor Phil
prototype.
Bell says that he thinks he can fix Doug in a few hours. Would you be willing to talk to Professor Phil Bell?
100%.
All right, I will. I'll give him your email address.
Sure.
And,
Also, that should be at the bottom of this page, bottom of every page.
okay, Professor Phil Bell. In the description of this video is Doug's website, so you may be able to find his contact information there. So shoot him an email.
I don't even think I have a contact.
Okay.
Page.
Cretan Ball has been a member for 48 months. That's 4 full years of this great nonsense. Ha.
A member of your subscription?
Yes, he's been a member of my channel. Yeah.
How long have you been streaming?
5 years. Bit over 5. It was 5. Let's see. No, my first live stream was April 1st of 2019.
That didn't even seem like it was long ago until I realized it's 2024. Holy shit.
Yep, it's coming up on 5 years of streaming. My first debate was April 20 of 2019.
Ah, my grandfather's birthday.
With, is his name Adolf?
No.
Oh, good.
He was on the other side of that war.
Okay. Because that also is Adolf's birthday, by the way.
I'm fully aware of that.
And Daryl Strawberry.
Is that a birthday or
Cameron Electra. Why do I know these things?
It's an interesting date.
Some things fall off of the memory shelf and some things don't. They just won't leave.
Yeah.
Carmen Electra and Daryl Strawberry's birthday is the same day as that guy that Caleb likes so much.
The first person you mentioned? Adolf?
No, yeah, Adolf is the guy that Caleb likes so much.
Oh. It's that kind of YouTube following.
Yeah, Caleb. Do you know Caleb?
I don't know who Caleb is.
He's a flat earther. He loves Adolf. He's a big fan of Adolf's work.
I don't think that's a good idea.
No,
broadcast.
No, it's not. But he does. He posts it on Twitter often. How much of a fan he is.
Imagine a world where there was no government to protect people from the consequences of what they say.
Yeah. All right. Streeters One says that your model is the plum pudding model for the win.
Take it back one notch and go to Bohr. We don't have electrons in the atom. We have an atom all by itself with electrons somewhere else.
So how does semiconductor circuit boards work then?
Good question. Ask somebody who knows.
I mean, I know, and you know, electrons in them is important instead of electrons all hanging out in the sun.
For engineering purposes, we can continue to assume that the electrons are there. For conceptual, theoretical discussions, we're trying to update our understanding of the atomic model and the universal model with the possibility that it's not the electrons that are interacting, but it is the ether that is interacting the electronic charge from one proton to the next, like a vibration. If the circuit board is made out of protons or mass, and each proton is attached to an ether, then it is safe to say that the circuit board is attached to ether. So
So
if
hold on. This is new. So you can say an ether, so an ether particle.
right, for every proton in the universe, there is a single spring of ether that is attaching it to an electron somewhere residing either in the center or slightly offset from the center of the universe. So I'm saying fundamentally, conceptually, that all the electrons are close to the center and all the mass is centrifuged away. But mass still retains all of the properties that we observe it to have, as if the electrons were there under our current understanding. We just have to understand that we're not looking at the interaction of an electron, we're looking at the interaction of an electromagnetic wave transversing through the ether.
So output coupler is asking how much does an ether weigh, and can you report this weight in sheep units?
Probably not in the specified units, and I doubt it has any weight if it has the ability to move through matter, or if matter has the ability to move through it. If it has the ability to exist in empty space, undetectable for all of the history of science, then perhaps it has some properties that are very unlike what we understand matter to have,
All right.
such as weight.
All right. Facty wondered what college you went to. Was University of North Carolina?
Wilmington.
Wilmington. All right.
UNC is in Chapel Hill.
Okay. MK Ultra says after listening, we don't think. All right. He can be a little rough sometimes. He says we don't think you're a dumbass. We know you're a crazy person. So
I agree with that.
It's
But I would also ask what the definition of crazy is before I totally agree.
I mean, it's swings and roundabouts, right? Am I right?
Like Chutes and Ladders?
I don't know. It's something they say across the pond. I don't quite understand them. I don't think they do.
Most. Go ahead.
Alyssum says I'd say Occam Razor applies, but that would mean he'd have a matching explanation for reality. Should have just finished school, mate.
I gave it a good attempt. 6 times, almost $100,000 in student loan debt, of constantly disrupting class in order to argue about fundamental laws of light and gravity. And it was better for me to drop out and try to write a book that was easy for third graders and similar-minded creative people to understand than to sit there and argue with people who were invested in their current understanding of the universe.
All right. PG Tony corrected me. It's not swings and roundabouts. He says it's springs and roundabouts.
Oh, even better. Boing.
Lovebot says, is this a what if lost episode?
It'd be nice to get some publicity, such as televised interviews or whatever what if episodes are.
Yeah.
Oh, that's I've seen that on YouTube a couple times.
Hoax Police says, huge thanks to you, MC, FTFE, Peachy, Tony, Bob the Science Guy, Mr. Sensible, and of course Ian, for the fun, the truths, and general giggle you give me and all who watches. Big thumbs up. Hoax Danny Jones Hoax Police is a he kind of came around through some of the anti 5G craziness debunking.
So did he say it was good or bad? The towers.
5G is safer.
Great. I was getting a little worried about scrolling through Instagram with my phone on my chest for so many years.
The casual engineer says that this is worthy of the Nobel Prize.
Casual engineer. That's quite the name. I can vibe with that.
Yeah.
A very complicated discipline mixed with a very relaxed phrase.
Okay, this is a good question. IC Spin says, what's the fundamental reason you believe in Concave?
The mirages. They drive me crazy. Every time I get on the road, I see them, and I think there's a better explanation for why they're there, and everybody's overlooking it because of the current easy, simple explanation. I'd love to, if I could somehow get a pathway in school where I could just focus on studying mirages and vacuums, I think I would do a lot better service to the world than to just sit here and argue on YouTube. But it doesn't seem to be in the plan.
You could
I've
get
tried
a
that route.
you could get a book on optics. You could
You could. You have to
read
learn it. You have to find the time to read it.
read the stuff from Dr. Andrew Thomas Young at San Diego State University. A lot of good stuff on the properties of light as it passes through differing mediums in the air, differing densities of medium.
I understand how different densities affect the speed of light and the curvature, but light bends towards the normal when you go into a different density medium. So, but if I remove all the air, we don't have to understand how light moves through gases at all. We can only focus on how light moves through empty space. And
Yeah.
if it moves the opposite that we expect, then there must be some other reason that we can
But
dive into.
this started the question, why you dropped it, or why you came to this position, and your fundamental test has not even been performed. So your reason why is actually kind of falls apart, doesn't it?
There's the mirages that you see close to you on the road, but then there's also the mirages from very far distances. And I've seen boats on the horizon. I've seen planes. I've used those apps that track the location of those vessels. And every time I've done it, it always shows that you shouldn't see this boat. You shouldn't see this plane. It should have dipped below the horizon by
Actually,
now.
that's not correct at all. Every single time I've ever been presented with anything from flat earthers, typically talking about should you be able to see this, every time the answer is yeah, we should be able to see it. But they refuse to actually apply the globe model. They always strawman the globe.
My math is not wrong in this section where it suggests that the Sears Tower should be exactly 100% concealed. My numbers are 1,400 feet should be concealed at 50 miles.
Assuming zero refraction. But we know that there is refraction, so you're strawmanning.
Ignoring refraction. Now, this is why I have to study on how light moves in a vacuum. If light were to transition, as you say, in a gaseous environment, there should not be a perfect translation of the image. There should be a very randomized, distorted version of that image at best. But because the fact that light moves so smoothly, so homogeneously over such vast distances suggests that there is a more fundamental concept that is underlying what's going on here. The explanation for gaseous interference doesn't do as smooth of a job convincing me as the fundamental curve of light in the concave model. So it was the inspiration and thinking about how the image was so undistorted was the doubling down method, essentially, that got me to want to do it in a vacuum chamber to prove that there's a natural curve and it's not just a gaseous interference.
All right. Stringer News 1 is wondering about dropped on head. We'll skip that. The Sun Express says interesting.
I actually was.
What's that?
I was.
All right.
I'm glad you asked.
The Sun Express
Superpowers unlocked.
Says interesting how unhinged quackery always makes sense only to the quacks.
Well, I'm sure it will make sense to the not so quacks once it becomes irrefutable and there's an abundance of data to show it. But yeah, someone's got to dive in head first and figure out if it's right or wrong. And so far, I'm unsure if it's right or wrong.
All right. Globe explains says the only evidence of a concave Earth is that shoes are always worn out at the back and front, not the middle.
I don't understand the structure of that comment. Could you say it again?
Well, are you serious?
I'm confused. If what I say confuses you, you surely can understand.
All right. So a
Maybe a diagram would help. What?
all right, hold on. I'm gonna stop your screen share. There you go. So if you have a concave earth like this, right? Your shoe, the front of the shoe and the back of the shoe would be
Right.
what hits the ground in a
Mhm.
significantly exaggerated concave earth. So only the front and back would be worn out from walking on it.
Right. If not for the fifth dimension causing the surface to
It's
act flat.
that fifth dimension again, damn it.
It's the idea of the whole theory.
It's always the fifth dimension or the springs or the ether particles.
Well, the ether is the spring.
Oh, ether is a spring.
Yeah. The spring is what the
Uh,
light travels through. From one spring to the next, it
it's like a
induces
fiber optic
electromagnetic waves.
springy cable.
Now that's word salad.
There you go. MK Ultra says he hasn't left the house. I suggest Marissa as a good match for him. They could get hitched.
I don't like the sound of that.
Well, Marissa is unspoken for, to my knowledge. And are
I'm surprised you
you
didn't have
are
a
you
green screen in the software.
are you still unspoken for?
I'm sorry, say that again.
Are you still unspoken for?
What, you mean unmarried?
Yeah,
I'll let
I'm.
you take a wild guess.
I'll. Alan is saying, yeah, you're
Thanks,
unspoken
Alan.
for.
Uh, it's not in the game plan.
Well, I don't know, Marissa. We'll make it happen. Um,
Here's an interesting way of transitioning out of that. My retirement plan is to prove this once and for all by getting into a spaceship, going into one direction for as long as I can possibly survive, and having shown that I can live for hundreds of years extra from my observers left on Earth. They're going to watch me for hundreds of years live longer.
you
I
think you
don't have
can?
any audio.
You think
Okay.
you can actually listen to One Direction that long? I mean, I might get through two,
I've been
three
saving
albums,
up
but
the
but
movies. I wasn't
but
going to listen. No,
but
not
that'd be
listen
it.
to, travel in.
Do you? I should do a poll. Do people prefer One Direction with or without Harry Styles?
I didn't know he was no
Yeah,
longer with them.
yeah. Hold on, I gotta. Yep. Yep. I'll make the poll here quick. With Harry Styles and without.
It's just a random thing to be pulling in the middle of this.
Yeah. Well, I mean, you were talking about hair. You were talking about One Direction.
Yeah, straight up.
All right, there it is. There it is. All right, Peachy Tony says, if I understand this guy correctly, gravity isn't real. How does gravimetric mineral exploration work? And how do satellite orbits work? We got a twofer here. Thanks, Tony.
Satellite orbits works fundamentally the exact same as the moon's orbit works. And when you go to the moon, you exist in the same spot that the moon exists under those same forces. So when you break away from the Earth's centrifugal downward force, which is the main component of that we experience of gravity, you can, just like in the ball and space model, you can suspend yourself by balancing the downward forces with your straight line maintained momentum. I don't know. What was the first part of that question? It was a twofer.
How does gravimetric mineral exploration work? I'll explain that. There are satellites a pair of satellites that orbit the Earth. They're in contact with each other through a laser. The laser is very, very precise in measuring the distance between them. As one of the satellites goes over an area of the Earth with slightly higher gravitational pull, it accelerates as it does that. The one trailing it measures that difference in acceleration as a difference in
Hmm.
distance. And then, of course, it does the same thing. And then the other one pulls away, um, or no, sorry, it compresses that distance, changes by getting shorter. Anyway, so that allows an incredibly precise gravimetric map of the entire Earth over time. And so gravimetric mineral exploration would use these fluctuations in the density and increasing and decreasing amount of gravitational acceleration to identify more massive or less massive areas underneath the surface.
That sounds like it would be better suited for the college level book, college
Oh.
level version of my book.
All right, there
I
you
can
go,
see.
Tony.
I mean,
Someday.
I would love to dedicate my life to answering questions like that, but as far as I'm concerned, I have to keep paying my health insurance and other various bills.
So, MK Ultra says, how do we get to space from concave Earth?
Up is in. You just do the exact same thing you always do. Treat gravity as if it's pulling you down, 9.8 meters second squared, and then just counter that with enough thrust to go up until
But
you're
but
there.
but in the globe model, we use centrifugal force. Or sorry, centrifugal force to as the counter to gravity. But in a concave model, the centrifugal force would accelerate you toward the ground.
Right. When you are moving with the Earth. If the Earth is moving around once every 24 hours in a circle.
But in concave Earth, it's stationary, right?
No. The concave Earth is spinning. The whole universe is spinning. That's why the atom is the way it is. The thing that causes the protons to be on the outside is the same thing that causes your feet to go towards the ground. It is Newton's first law. Objects go in a straight line unless they're redirected, in which case you experience the opposite force.
That doesn't work. No, that doesn't work. Not even. Okay. You say that the concave Earth is rotating.
Right. The atom is rotating.
And so
make that point very clear at the beginning of the book.
The centrifugal force is what then causes people to be stuck to the surface of the inside of the Earth. Right?
Well, it's one out of two parts. But yeah, it's the main force that we experience is that downward acceleration is due to mostly centrifugal force.
Okay, so at when you're at the equator, there's going to be a certain amount, and we could calculate based on the radius how fast it would have to go to get 9.8 meters per second squared. It would have to be quite a bit faster, like 1,000 times faster than the globe rotates. But at the same time, hold on. At the same time, at 60 degrees north latitude, that downward acceleration would be cut in half, and the vector would be dramatically different in relation to the surface of the inside of the concave Earth.
Except you neglected the part that the Earth is on a 23-degree tilt, and if it's wobbling the other direction, you've got a 46-degree variation in this model, which is half of 90 degrees. And so if you look at what a water does when you spin it around in a circle, I'll try to find the video of it real quick, but
I tried.
Centrifugal spinning of water creates spheres. A sphere vacuum, essentially, in the center of a... give me a minute. I'm going to find this video.
Oh, my
God. If only I was prepared.
Yeah. Let's see. Professor Phil Bell is not able to find your email address on the website. Oh, CapQ57 says that I'm ignoring the fifth dimension. Oh, yeah.
Well, yeah, you don't have to assume it's there because you never experience it. You only experience it indirectly when measuring the ticking of time at various altitudes.
As Hateful Keating measured. Oh, PhD Tony. You're making too much sense here for him. He's looking. He's looking. How you doing, Alan? Let's do this. Let's bring Alan. Alan, you want to say something? You can talk.
Oh boy.
Hello?
All right.
Oh boy.
How you doing, Alan?
Hey, how you doing?
Good. So Alan's been here the whole time, just silently watching, and Doug's looking up something. So I thought it'd be nice to say hi to Alan for a minute.
Well, thank you. I appreciate it.
Well,
Yeah,
what do you think of this
very.
this stuff here?
I'm learning a lot. I'm learning a lot of stuff here.
Okay, I found the video I wanted to show you.
Okay, that's it. You're being nice, Alan. I appreciate that. I'm sure Doug does
Yeah, no
too.
problem.
He's got
Yeah.
that southern hospitality, you know.
All right, you gonna share this, Doug?
Oh, sorry. Oh boy, I gotta rejoin the meeting, I suppose.
Oh no, it's there.
Okay, no. Share screen. I got it. Okay, so here's an isolated body of water that's being centrifuged. And notice the curve that it takes. I'm saying that essentially this is the same force that causes the Earth to be the way it is.
Okay. Yeah, that does that totally that's a problem then.
Well, what I'm saying is that if the force is there to make the water be a certain shape, then the same force will apply to anybody, assuming the water was, say, solid. If there was a person standing in that system, they would experience the same force. So they would be on that surface as if it were perpendicular, and if light didn't travel straight, could appear flat. So I'll stop sharing now that we've seen it 5 times.
All right.
Stop share. Huh.
Okay. So we've got PhD Tony says we use the geometry of satellites moving under gravity to study Earth's gravitational field. How does this work in your model?
Well, when we calibrate equipment, we assume that what we're working with is gravitational forces. So when designing them and using them to test real life data, we get what we expect. So this has nothing to do with the functionality of the equipment. The equipment works as calibrated. What it has to do with is reanalyzing the data from a conceptual standpoint, not necessarily looking for something that isn't there directly.
Okay. Facty is I think he's kind of a mechanical guy, kind of works on cars and stuff. So Facty is wondering if these are leaf springs or coil springs.
Coil. They were coil, they stretched out, so nearly straight lines at this point.
Alan's laughing at that.
That's the funniest thing I've ever heard. I like cars too, by the way.
All right. The Beacon says, did ChatGPT make it? Did you have ChatGPT make any of that for you?
All of the artwork, not the diagrams. I use Google Drawings for the diagrams, but the artwork on the beginning of each page or the beginning of each chapter, that was ChatGPT 4 point something, whatever. I did that only a few months ago.
Oh yeah, because there's the if you pay for ChatGPT, you can get it'll make images for you.
Yeah, and it's worth it 100%.
All right. The question is it better than how does it compare to Midjourney? Okay, so I'm gonna all right, get your votes in for the poll, people, because I know you all want to know. All right.
Yeah.
BM Furball says, I don't know how it works, but I'm right. Is the definition of Dunning-Kruger.
I don't know how it works in every single case of possible physics. I do know how it works conceptually, starting from a single assumption and deriving each step along the way.
All right. William Foley says, I hope Doug gets the help he needs, but it's probably not the help he thinks he wants.
Well, it depends on what he means by help, I suppose. If you want to get me to see a psychiatrist, I've been to psychiatrists. They don't help because my problem isn't internal, it's external. I'm trying to do something that the world doesn't want me to accomplish. But if you're talking about help in the sense of getting me to the point to where these experiments are completed and I have a determined answer or a definite answer, then that would be great. I wouldn't need a psychologist. I would just go back to work and feel good about the way I spend my time.
All right. PG Tony looked at your graph, your little chart of the dip of the horizon,
Yeah.
Doug, and you wrote it was the secant of theta times I forget the exact formula, but
Right.
actually adjacent over hypotenuse is cosine, not secant.
I'll double check it.
So,
I
yeah.
spent a lot of time on that page, I remember, so I'm pretty sure I came across the right answer, but I've made careless mistakes before, actually. But it would be better to
Redacted.
have a
All right.
team of
Hold on.
underdogs.
Redacted is asking if when you did see somebody, was there a diagnosis?
Yeah, ADHD. But that was from like second grade. It could be whatever you want to call it. I don't believe it's a disorder or what's the word for it? Attention deficit. It's not a deficit. It's literally me with a mind that wants to do so much, but the resources aren't there. So the frustrations amount. And you tend to not get along with everybody when you want to do something incredible with your life and you're forced to drive people around for $1 a mile.
Yeah. All right.
Excuse me.
Tim Davidson says a sphere around a sun to collect 100% of its energy, theorized by a man named Dyson, the Dyson sphere.
Okay. But that would assume that that the energy goes straight in all directions. In this model, if the source of energy is on one side, the energy can only reach half of the sphere. The other half will miss the sphere and retract and go back towards the center. Just like it does in the current model, as the Earth's shadow.
But then what are the stars?
The stars are the electrons that are close to the center.
And they stay still, mostly. They
Well,
move,
they're moving. But
they
they're
move
in a
only
region-
slightly.
Well, they're moving really quickly, realistically, but the speed of light is so slow where they are that they appear to be essentially frozen in time, very large and very far away. Which is the same thing that the Voyager is experiencing, is that apparent slowing down of its speed. If you saw an electron moving close to you, you couldn't see it because of how fast it would go, but close to the center of the universe acts like a microscope that slows down whatever it's observing.
Okay. BM Furball says I can't understand its size. My brain breaks. It must be false. All right. Professor Phil Bell talked about talking to you. What is your email address? Well, maybe send it to me. I'll do it after, so people don't. You don't want people to
you
get
can
it.
type it in. It's public information. It's follow and then my last name. So follow DeArros, which is also the name of my business.
At
gmail.com.
gmail.com. Okay.
I assume that everybody has Gmail.
That would be wrong.
Probably right.
Do you know what I do for a living?
You work with really smart people and do things that most people don't do.
I write email software. And yes, the people I work with are very smart. Yeah, so the email software I write is not Gmail. So in fact, all of the people that are the customers of my company don't use Gmail. So
smart people don't use Gmail.
Well, some smart people do use Gmail. I don't think you can draw a whole lot of conclusions.
That is a proper approach to that logic.
There you go. Lord Illuminous Pooh says, with that green square, we can put him anywhere.
That was the idea behind it. I thought you were gonna, I don't know if Zoom had the ability to eliminate the green screen.
Oh, yeah, but it's all on your side.
Well, it's a bit late for that.
Yeah, I guess I could have done it with OBS, but
No, it's too late now.
It can put you in space. Knock it off, Flurf 24 has dropped in the first super chat. His or her first super chat, but it's for $1, so there's no message. So thank you for that. Lord Illuminous Pooh says there's a lot of nuts in that word salad.
Nuts are a sustainable source of protein. Don't be afraid to get your sources from the nuts.
Yep. Go ahead. All right. Lord Illuminous Pooh. No, wait. So PG Tony says, what causes the P wave shadow zone? Why are the arrival times of surface seismic waves linear with time? What are SKS waves? All of these things are well explored in the field of seismology that you will need to explain with predictive capability for your model.
And if my first 2 experiments prove conclusive that this model has the ability or the merit to continue, then I will be happy to spend my whole life learning these things one at a time and reshaping my approach to explaining them, or reshaping the approach to explaining them so that it can fit into my model.
All right. Lord Illuminous Pooh comes again and says it's almost 40 years since Chernobyl and not one superhero. Come on. Right? Nobody.
Not one that's made his debut properly. They could be out there.
Nobody's flying around. Nobody's running faster than the speed of light, which apparently is
Somebody
variable
was
now.
running faster than the speed of light. How could we even acknowledge that? How could we even observe that?
Well, because the speed of light in your model varies, so they just need to go where the speed of light is slower and then run faster than it.
Right, but the physics, the laws of physics themselves change as the speed of light
Doug,
goes.
you're not the one to be talking about the laws of physics. They do whatever you want them to do.
Oh, you're talking about? Well, yeah, I guess if you're writing a comic book, which is, I guess, the current classification of my work, fiction.
All right. Lord Illuminous Pooh wonders, where is Voyager 1 and 2 at? You kind of explained it, but do it again for him.
They're on the way away from Earth. I don't know where they are exactly. I don't have that data in front of me. I haven't looked it up in a few months. I just conceptually confirmed that it is slowing down by looking it up and seeing that there's a discussion about it and as to why. And the current explanation for gravity of the sun doesn't make sense because it shouldn't be slowing down with an increasing deceleration. It should be slowing down with a decreasing deceleration, which means like the brakes should be getting loosened as it gets further away from the sun, not increased in pressure.
But you didn't test that though.
I don't have the ability to test that. I only have the ability to Google what is currently happening in layman's terms.
You have the ability to Google?
Yep.
Google works for you, right? All right.
Yeah, that's all I got.
All right. Demon Stride says concave for the win.
Concave to the win. Well,
Or the win. He has declared you the winner.
For the win.
Yeah.
I like that. All right.
And then
Find some
MMM
support.
Rules. That's the name of his Discord server. So are you on Discord?
Yes.
Get on Discord. Get on the Medicinal Mass Media Discord server. I think you'll enjoy it there. I can hook you up. Let's see. The Sun Express says, my dude. From my balcony, I can look straight across Lakeshore Drive over Lake Michigan to the opposite coast in Michigan. Only on extremely rare weather conditions can we see any part of Michigan.
Right. But the presence of fog.
I don't think that's what he's talking about.
You said only clear conditions?
Yeah, rare conditions. Yeah.
Okay, so define rare. Like what are the rare conditions? I'm assuming that when there's no fog.
Yeah, it would be temperature primarily.
Okay. But if we remove the air and if we examine how light moves in a vacuum chamber, then we can get a better understanding of it and not have to rely on the explanations that are hard to test, such as long distances and the atmosphere's effect on the path that light takes over that distance.
All right. PhD Tony says gravitational acceleration varies with location. If it were due entirely to rotation, it would vary only with latitude. And that's kind of what I was getting at. Right?
Yeah, I guess we just have to approach the problem from a larger scale and reanalyze it from there. I'd like to learn more about how liquid acts in a centrifuge, like it did in that video that I showed, because it kind of supported the fundamental concepts that I was explaining, that in a spinning system you will get a sphere in the middle of it where all matter goes away from, not just a vertical column,
because it's
column.
rotating under the influence of gravity. It's parabolic.
Right, and I'm saying that the reason that the Earth itself is a sphere is because of that rotational effect. If I guess if it were spinning faster and there was a wall to push up against, the Earth would be a tube, but that's not what we experience. So the theory doesn't try to explain the tube Earth; it explains the spherical Earth, and it uses the current laws of physics that are visually grasped by the video that I show to support that.
All right.
How you doing, Alan?
I'm good. I'm just listening.
People can see you right now, and just
Oh, hey.
Coffee Breath says, so if I flew from Alaska to Sweden by going over the North Pole, I would first have to traverse through the farthest point of the universe.
No, because your altitude is respected as your altitude. And when you travel over the surface of this model, it's essentially like traveling over a flat surface. So you increase the distance you spend traveling when you ascend and when you descend. But once you get to your cruising altitude, the horizontal distance that you take is going to be the same as if you were on a boat, essentially. I'm just saying right now, with how large the Earth's radius must be in order for gravity to exist the way it does, that difference would be so small that we wouldn't be able to detect it by chance. It would be something we look for.
All right. I'm trying to set up your green screen. But I'm not having much luck.
I've learned to stop trying to edit during the broadcasts. Just write it off for a lesson learned.
We can put some springs back there.
Some leaf springs.
Yes, car springs.
All right, I'll get that. I can Science that says, does this guy have any math we can use to like build anything or predict anything, or dare I ask, test anything?
Yeah, there's a couple parts of the book that I attempt to put my explanations into the mathematical format. I don't feel like going through it right now, honestly, but you can download the PDF and look through it for yourself if you'd like.
All right.
I think focusing on the altitude of a horizontal beam of light would be the best place to start. In a vacuum chamber, of course.
And you've said that you've started on that some.
The experiment?
Yeah.
I built it to where it was functional enough to hold a vacuum, but I wanted a surface that had no reflection, and the paint that I bought, which was like BLK 2.0, it still had a bit of a shine to it. And so I got discouraged when I realized that Vanta Black was so exclusive. You had to like apply to get it.
Yeah, well, just get regular black then.
I mean, the black that I bought was supposedly the most absorbent paint that you could buy, and it still had a bit of a shine to it. And I didn't want anybody to say that there was a reflection being observed versus a mirage. So getting the publicity necessary to, convince the Vanta black guys to let me use it would be a dream come true, I suppose.
All right. You know what? I'm gonna get this. Oh yeah. I'm gonna get your green screen working.
Oh,
Yay.
thought you were getting in contact with the Vanta black guys. Anish Kapoor, is that his name?
There we go. Got it.
Hey.
All right. David Brock says he said the ether is a spring. Does he have some version of Hooke's law for its behavior, or is it described as a capacitor?
I mentioned Hooke's law only to describe its behavior, but I don't know what he means by a capacitor. I mean, I know what a capacitor is with regards to like circuit boards and electric circuits, but I don't know what he means by it.
All right. Well, maybe we'll look it up. Peachy Tony says, why does the length of day vary throughout the year? Why does it vary after large earthquakes? What is the cause of the true polar wander?
Great question. Wish I could answer it.
You got a lot of things to answer. All right. Some people are saying
not...
that Musou black is, I'll look it up quick for you, is easier to get your hands on.
I'm gonna go through this recording later and make some notes of what I was supposed to write down.
I'll just send you that right now. Musou black. You can look that up.
Awesome. All
right. Borg Emporia says, Happy New Year, MC Toon. Thank you, Borg Emporia. Professor Phil Bell says he will help you design experiments.
Whoa.
There you go.
Oh
wow.
Let's get it over with.
It sounds like Muso black. Lord Illuminous Pooh said, I said on FTFE, but everyone thinks Neil Armstrong was the first man on the moon. Incorrect. It was Mr. Takashi. He was a gardener from Nagasaki. Too
Some
soon?
overlooked history?
Too soon.
Or was that a joke?
It was a joke in bad taste and yet still funny. And then Lord Illuminous Pooh said, stupid spell check. It should be Neil, not new. I fixed it for you on the fly. All right. What do you think of the background I added for him? Do you know what it is, Doug?
I don't have a clue.
It's the blue marble.
It's not springs.
It's not springs. It's the blue marble from 1972.
Oh, nice. I know
you're
that
flying in space above the Earth as it rotates in real time.
Nice.
Okay. All right. Somebody says check my Discord from Zoomy. Oh, there it is. All right. I will send you. Zoomy sent the link for the black paint. There it is. Muso black paint link you've received. Lord Luminous Pooh says, I am the world's foremost collector of Velvet Elvis, the Greek plural of Velvet Elvi. The Greek plural of Elvis. Say Elvis too many times and you start saying things like, my precious.
Okay.
All right, let's get both your vote and Alan's vote for is a One Direction better with or without Harry Styles? First, Doug.
Well, to be totally honest, I don't listen to any music, so I don't know.
That's the wrong answer. Alan, what's the right answer?
I would have to personally say Harry Styles. Gots to be there.
All right. All right. Well, that's good to know. All right, here comes. If it's a tie, you will be the tiebreaker. And it's close. With Harry Styles 50%, without 49%. And of course, YouTube can't do math. There's a missing 1%. Yes. So with Harry Styles wins.
Barely. By popular vote.
Out of 149 votes, out of 490 people watching, it was not a popular vote.
Hey, if just it was the loss, man.
I would say with. That's I'm on the with side. I don't know why Doug is on the without side.
I'm not on the without side. I'm on
why you got to be like that, Doug?
He's different. That's how it goes, you know. You see what I deal with every day?
Do you live somewhere near him?
We live in the same state.
Okay.
Yeah. It's a very deep past.
All right. Well, let me say this, Doug. I talk to Doug every once in a while. We've kept in touch since the last time he was on. I like Doug. I like you, man. I
like Doug too.
I think you're off your rocker completely. I think you've tossed the rocker over the dam that the guys in Australia throw stuff off of. Those guys. You know what I'm talking about?
I'm gonna look it up after this.
Those guys.
Yeah, me too.
But I like so if anybody's interested in Doug is you do stuff on Kick, right?
Yeah, I'm trying to spread out and like leave a what's the word for it? Leave an imprint on the internet before I disappear off this earth. That was way too deep.
Yeah, man. It's too soon. It's too dark, man.
Tell me about it.
So, all right. Well, I think it's we've gone on for a while. I think it's time to move forward.
Yeah, I'm mentally exhausted.
So if they want to find you, your website's linked in the description. Is there any other way to find you?
I don't know, man. Just Google it, I guess. I'm working on my whole marketing strategy, so yeah, whatever links you see, that'll be your best bet.
All right. Google Doug DeArros. Is that how to say it?
It was like DeArros.
DeArros?
That's the whole inspiration of the business name, was like follow DeArros, like the arrows.
All right. Well, thank you very much, everybody. I've got another live stream in just over 10 minutes. Be sure to jump in for that, and we'll see you all there.
It's been a pleasure.
Here we go.
MC Tune, drop that beat.
All right. Let it flow. Let yourself go. So I know that is the tempo.
So, yeah, let's do this.
Let's do this. Yo, it's MC Toon, the debunking tycoon. I shatter flat earthers, make them face the moon. Your attempts are decent, but they'll swoon in the face of my logic like a deflated balloon.
Oh, MC Tune, the one to soon cartoons. Unreal say send flirts to their views. Your theories are like old brews, sweeping ignorance or just spreading the views.
FDFB stands for fumbling the facts evidently. I drop truth bombs so splendidly. Your approach is soft, mine's unrelenting. I bring the science while you're just venting.
MC Tune, the platoon with silver spoon. I tackle pseudoscience, make them change their tune. You're the sidekick, I'm the room. When it comes to debunking, I'm the room.
But hey, FTFE, we share the creed to educate and debunk, plant the seed. Though in this rap, it's clear indeed I've got the upper hand, then word indeed. All right, hold on a second. The Zoom call died. Everything died. No.